Hello, hi everyone. I welcome you all to the Vedantu Karnataka. So, ನಾನು ನಿಮ್ಮ master teacher Rithika Ma'am. So, ಇವತ್ತಿನ chapter chemical equilibrium for the NEET purpose. Okay. So, NEET ನಲ್ಲಿ ಯಾವ ತರ chemical equilibrium questions ಅನ್ನ ಕೇಳ್ತಾರೆ ಅದನ್ನ ನಾನು ನಿಮಗೆ ಐಡಿಯಾ ಕೊಡ್ತೇನೆ. ಯಾವ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇಂದ ಕೇಳ್ತಾರೆ ಅನ್ನೋದು ಐಡಿಯಾ ಕೊಡ್ತೇನೆ. So that your preparation will speed up. Clear? So, please confirm me whether I'm audible and visible properly or fast ಆಗಿ. ಓಕೆ, ಸ್ವಲ್ಪ ನನಗೆ ಹೇಳ್ಬಿಡಿ ಫಾಸ್ಟ್ ಆಗಿ. ನಾನು ಆಡಿಬಲ್ ಅದೇನಾ ಸರಿಯಾಗಿ? ಎಸ್, ಐ ಆಮ್ ಆಡಿಬಲ್ ಪ್ರಾಪರ್ಲಿ. Okay, then let's start the class then. So today we are going to discuss about the chemical equilibrium. This is a first PUC chapter. It's actually a first PUC chapter. One second, guys. ಮತ್ತೆ ಫಸ್ಟ್ ಪಿ ಯು ಸಿ ಚಾಪ್ಟರ್ ಇಂದ ಫಸ್ಟ್ ಥಿಂಗ್ ಅಂದ್ರೆ ಏನು ನೆನಪಿಟ್ಕೋಬೇಕಂದ್ರೆ ನೀವು, ಇಟ್ಸ್ ಆಲ್ ಅಬೌಟ್ ಹೌ ಮೆನಿ ಮಾರ್ಕ್ಸ್ ದೇ ವಿಲ್ ಆಸ್ಕ್. ಓಕೆ, ಇಟ್ ಇಸ್ ದ ಫಸ್ಟ್ ಪಿ ಯು ಸಿ, high weightage also it is. It's almost asked 2 questions from this chapter, 2 questions from this chapter, plus how many marks? 6 to 8 marks will be there. Okay, 6 to 8 marks questions they will be asking from the chemical equilibrium. Clear? So chemical equilibrium is a very easier chapter, plus ಏನ್ ಬೆನಿಫಿಟ್ ಇದೆ ಇದ್ರಲ್ಲಿ ಅಂದ್ರೆ ಡೈರೆಕ್ಟ್ ಕ್ವಶನ್ಸ್ ಕೇಳೋ ಚಾನ್ಸಸ್ ಜಾಸ್ತಿ ಇದೆ. ಯಾಕಪ್ಪ ಡೈರೆಕ್ಟ್ ಕ್ವಶನ್ಸ್ ಜಾಸ್ತಿ ಕೇಳ್ತಾರ ಅಂದ್ರೆ, ಇಟ್ ಡಸಂಟ್ ಹ್ಯಾವ್ ಎನಿ ಕಾಂಪ್ಲಿಕೇಶನ್ಸ್, ವಿ ಡೋಂಟ್ ಹ್ಯಾವ್ ಎನಿ ಅಪ್ಲಿಕೇಶನ್ ಬೇಸ್ಡ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇನ್ ದಿಸ್ ಚಾಪ್ಟರ್. ಅಂಡ್ ಮೇನ್ ಥಿಂಗ್ ಇಸ್ ಅಬೌಟ್ ಇದು 6ರಿಂದ 8 ಮಾರ್ಕ್ಸ್ ಕೇಳೋದು. ಅಂಡ್ ಮೇನ್ ಥಿಂಗ್ 2 ಕ್ವಶನ್ಸ್ ಅಷ್ಟೇ ಕೇಳಬಹುದು ಅದರಿಂದ, ಈ ಚಾಪ್ಟರ್ ಇಂದ. ಸೊ ಇದು ಯಾಕೆ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ? ಸೊ ಇದು ಬೇಸಿಕ್ ಆಗುತ್ತೆ ಬೇರೆ ಚಾಪ್ಟರ್ಗೂ. ಓಕೆ, ಇಟ್ ವಿಲ್ ಬಿ ಅ ಬೇಸಿಕ್ ಫಾರ್ ದ ಅದರ್ ಚಾಪ್ಟರ್ಸ್ ಆಲ್ಸೋ. ಇಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ಯು ಪೀಪಲ್ ಟು ಇಂಪ್ರೂವೈಸ್ ಯುವರ್ ಬೇಸಿಕ್ಸ್ ಫ್ರಮ್ ದಿಸ್ ಚಾಪ್ಟರ್. ಡಿಫ್ರೆಂಟ್ ಚಾಪ್ಟರ್ಸ್ ನಿಮಗೆ ಹೆಲ್ಪ್ಫುಲ್ ಆಗುತ್ತೆ, ತಿಳಿತಾ? ಸೊ ಯಾರ್ಯಾರು ನೀಟ್ ಪ್ರಿಪರೇಷನ್ ಮಾಡ್ಕೋತಿದ್ದಾರೆ ಅವ್ರಿಗೆ ಆಲ್ರೆಡಿ ಈಗ ಆಲ್ಮೋಸ್ಟ್ ಏನೇನು ಚಾಪ್ಟರು ಎಲ್ಲೆಲ್ಲಿ ಹೆಂಗೆ ಬೀಳುತ್ತೆ ಅನ್ನೋದು ಐಡಿಯಾ ಇರುತ್ತೆ. ಇನ್ ಕೇಸ್ ಯು ಆರ್ ವೆರಿ ನ್ಯೂ ಟು ದ ಚಾನಲ್, ದೆನ್ ಮೇಕ್ ಶೋರ್ you will subscribe to the channel first and then hit the like button. Clear? Yes. First time channel ಒಂದು ಕ್ಲಾಸ್ ನೋಡ್ತಿದ್ರಂದ್ರೆ ಫಸ್ಟ್ ವೇದಾಂತು ಕರ್ನಾಟಕದಲ್ಲಿ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಬೇಕು, ಆಯ್ತಾ? ಸೊ ಅಂಡ್ ಪ್ಲೀಸ್ ಡೋಂಟ್ ಫರ್ಗೆಟ್ ಟು ಮಾರ್ಕ್ ಯುವರ್ ಅಟೆಂಡೆನ್ಸ್. ಫಾಸ್ಟ್ ಆಗಿ ನೋಡೋಣ ಎಷ್ಟು ಮಂದಿ ಅಟೆಂಡೆನ್ಸ್ ಮಾರ್ಕ್ ಮಾಡ್ತಾರೆ. ಡೋಂಟ್ ಫರ್ಗೆಟ್ ಟು ಮಾರ್ಕ್ ಯುವರ್ ಅಟೆಂಡೆನ್ಸ್ ಆಲ್ಸೋ. ಎಸ್. ಸೊ ಹಾಯ್ ಎವ್ರಿವನ್. ಓಕೆ, ಹೇಗೆ ಪ್ರಿಪ್ರೇಷನ್ ಆಗ್ತಿದೆ ಎಲ್ಲರದು? ಸೊ ಇನ್ ಕೇಸ್ ಯಾರಾದರೂ ಬೇರೆ ಪಿ ಯು ಬೋರ್ಡ್ ಸಲುವಾಗಿ ಈ ಚಾಪ್ಟರ್ಸ್ನ ನೋಡ್ತಿದ್ರೇನು ನೋಡಬಹುದು. ಇಟ್ ಇಸ್ ಫಾರ್ ದಮ್ ಆಲ್ಸೋ ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ದ ಗುಡ್ ಓನ್ಲಿ. ಓಕೆ, ಅದೇನು ನಾನು ಸ್ವಲ್ಪ ಎಕ್ಸ್ಟ್ರಾ ಇದೆ ನೀಟ್ನಲ್ಲಿ, ಅದನ್ನು ಕಲಿಸ್ತೇನೆ. ದಟ್ ವಿಲ್ ಬಿ ಎಕ್ಸ್ಟ್ರಾ ನಾಲೆಜ್ ಟು ಯು ಪೀಪಲ್ ಆಲ್ಸೋ. ಓಕೆ, ಸೊ ಲೆಟ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದ ಚಾಪ್ಟರ್. ಫಸ್ಟ್ ಇಂಟ್ರೊಡಕ್ಷನ್ ನೋಡ್ಕೊಳ್ಳೋಣ. ಮೀನ್ಸ್ ಯಾವ್ಯಾವ ಥರ ನಾ ಈ ಚಾಪ್ಟರ್ನ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡಿದೆ ನಾನು ಹೇಳ್ತೇನೆ. ಸೊ ಐ ಹ್ಯಾವ್ ನಾಟ್ ಮೇಡ್ ದ ಥಿಂಗ್ಸ್ ಲೈಕ್ ಅ ಪ್ಯಾರಾಗ್ರಾಫ್ ವೈಸ್ and I'll going to sit and explain you people. I have made every concept in a point wise concept so that ನೀವು ರಿವಿಷನ್ ಯಾವಾಗ ಮಾಡ್ತಿದ್ದೀರಲ್ಲ ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ ಓದಲಿಕ್ಕೆ, ಆಯ್ತಾ? ಸೊ ಆ ಥರ ನಿಮಗೆ ಮಾಡಿ ನೋಟ್ಸ್ ಕೊಟ್ಟಿದ್ದೇನೆ. ಸೊ ಗೋ ಆ್ಯಂಡ್ ರೆಫರ್ ದೋಸ್ ನೋಟ್ಸ್ ಆಲ್ಸೋ. ಇನ್ ಕೇಸ್ ಇನ್ನಾದ್ರೂ ಏನು ಬೇರೆ ಚಾನಲ್ ಬೇರೆ ಸಬ್ಜೆಕ್ಟ್ಸನ್ನು ನಾವು ಆಲ್ರೆಡಿ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೇವೆ. KCET ಸೈಟ್ ಮಾಡಿದೆ, ನೀಟಿಗೆ ಸ್ಟಾರ್ಟ್ ಆಗಿದೆ ಕ್ಲಾಸಸ್ಸು, ಹೋಗಿ ಚೆಕ್ ಮಾಡ್ಕೋಬಹುದು ಎಲ್ಲರೂ, ಆಯ್ತಾ? Done? Then let's start the class. Everything is fine going? Everything is fine going? One second, guys. Okay, let's start with the class first. Introduction of what is the meaning of a chemical equilibrium. Okay, now before we know about the chemical equilibrium, let us understand about what is the meaning of a chemical reaction. Okay, chemical reaction is a process in which one or more reactants react to produce one or more products. So one or more reactant will react to produce a product. That at least we know, right? Chemical reaction andre enu? Yavaga one reactant to ಎರಡು reactant ಇಲ್ಲ 3 reactant combine ಆಗಿ ಯಾವಾಗ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಮಾಡ್ತಿದೆ ಅಲ್ಲ ಅವಕ್ಕೆಲ್ಲ ಏನ್ ಕರೀತಾರೆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅಂತ ಕರೀತಾರೆ. Now we have two types of reactions in it. First one is what? Irreversible reaction. Next one is reversible reaction. So let's learn in detail about the reversible and irreversible reactions. So irreversible reactions are unidirectional reactions are known as irreversible reactions. So unidirectional, all the irreversible reactions will be unidirectional. Clear? So are known as irreversible reaction. That is, reactants convert to produce products. Reactants will convert to produce the products where products cannot convert back to the reactants. Products cannot convert back to the reactants. Means what? ಒಂದ್ಸಲ ಅಕಸ್ಮಾತ್ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆದ್ರೆ ಆ ಪ್ರಾಡಕ್ಟ್ ಮತ್ತೆ ರಿಯಾಕ್ಟೆಂಟ್ ಆಗಿ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. ಒನ್ಸ್ ಇಟ್ ಇಸ್ ಡನ್. ಈಗ ನಾ ಮಾತಾಡ್ತಿದ್ದೇನೆ, ಒಂದ್ಸಲ ನಾ ಮಾತಾಡ್ಬಿಟ್ರೆ ಮುಗಿದ್ಬಿಡ್ತು. ಈಗ ಅದು ಮಾತಾಡಿದ್ದನ್ನ ತಗೊಳಿಕ್ ಬರಲ್ಲ. ಸೇಮ್ ಅದೇ ತರ ಇರ್ರಿವರ್ಸಿಬಲ್ ಪ್ರೊಸೆಸ್. ಹೇಗೆ ರಿಯಾಕ್ಷನ್ ಮೆನ್ಷನ್ ಮಾಡ್ತಾರೆ ಅದರಲ್ಲಿ? ದಿಸ್ ಇಸ್ ದ ಹೌ ಎಕ್ಸಾಂಪಲ್ಸ್ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್. BaCl2 in aqueous solution where H2SO4 is being reacted to form BaSO4 plus 2HCl plus 2HCl. Clear? So these are some examples of irreversible reaction. Let's move to the next, that is about the reversible reaction. So reversible reactions occur in both forward and backward directions and therefore never go to completion. So means what? Whatever the reactant we are getting it, we are reacting, we are getting the product, that product, whatever this product is there, that can be converted to this and this can be converted to this. ಕ್ಲಿಯರ್? ಮತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗಿದ ತಕ್ಷಣ ಈಗ ನಮಗೆ ಆ ಪ್ರಾಡಕ್ಟ್ ಬ್ಯಾಡ್ ಆಗಿದೆಯಪ್ಪ, ನಮಗೆ ಸಪ್ರೇಟ್ ಆಗಿ ಮಾತ್ರ ರಿಯಾಕ್ಟೆಂಟ್ ಬೇಕಿದೆ. ಸೊ ನಾವು ರಿಯಾಕ್ಟೆಂಟ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬಹುದು. ದೋಸ್ ಆಲ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ರಿವರ್ಸಿಬಲ್ ರಿಯಾಕ್ಷನ್. ಡನ್. ಸೊ ಏನ್ ನೋಟ್ ಇದು? ಫಾರ್ ಎನಿ ರಿವರ್ಸಿಬಲ್ ರಿಯಾಕ್ಷನ್ ಕಂಟೈನರ್ ಶುಡ್ ಬಿ ಕ್ಲೋಸ್ಡ್. ಸೊ ಯಾವಾಗ ರಿವರ್ಸಿಬಲ್ ರಿಯಾಕ್ಷನ್ ಆಗ್ತಿದಿರುತ್ತಲ್ಲ ಅವಾಗೆಲ್ಲ ಕಂಟೈನರ್ ಏನ್ ಯೂಸ್ ಮಾಡ್ತೇವಲ್ಲ, ದಟ್ ಆಲ್ ಥಿಂಗ್ಸ್ ನೀಡ್ಸ್ ಟು ಬಿ ಕ್ಲೋಸ್ಡ್. That all things needs to be closed. Clear? Equilibrium means what? It is defined as the state when measurable properties such as position, speed, temperature, concentration and pressure do not change with time. They all will not change with a time. Clear? So ಏನೇನಾಗುತ್ತೆ equilibrium ನಲ್ಲಿ ಅಂದ್ರೆ, chemical equilibrium ನಲ್ಲಿ, this is important definition of chemical equilibrium it is. Okay? So ಏನಾಗುತ್ತೆ? It is defined as what? The state when the measurable properties such as position. So measurable properties like position, ಎಲ್ಲಿದೆ position, ಎಷ್ಟು weight ಇದೆ, ಎಷ್ಟು size ಇದೆ, ಇವೆಲ್ಲ measurable positions, right? Measurable things, right? Position, speed, temperature, concentration and pressure do not change with the time. So ಏನ್ measurable things ಇದಾವಲ್ಲ ಅವು change ಆಗಲ್ಲ according to the time. In case ನಾವು 1 liter of liquid ತಗೊಂಡಿದ್ರೆ ಅದು ಹೇಗಿರುತ್ತೆ ಹಾಗೆ ಇರುತ್ತೆ. ಕ್ಲಿಯರಾ? ಸೊ ನೀವು ಏನ್ ಮಾಡ್ರಿ ಅದೇನು ಚೇಂಜಸ್ ಆಗಲ್ಲ. Clear? That all things are called as chemical equilibrium. Means what? All the things are in the equilibrium form. All the things are in the equilibrium form. Clear? So now equilibrium can be of a number of types. Example: physical equilibrium, thermal equilibrium, mechanical equilibrium and chemical equilibrium. So in equilibrium we have a further types also: chemical, mechanical, physical. So these all things we will learn today. Okay? So now you people are clear with the reversible and irreversible? Yes? Hi. Clear adre ellaru? Reversible ಮತ್ತೆ irreversible ge? Done? Let's move to the next part then. Let's move to the next part. Next comes the thermal equilibrium. Now you need to know about the thermal equilibrium. Clear? So in thermal equilibrium, what you people are going to learn? In thermal equilibrium, one second guys. Yes. So it is that type of equilibrium where the thermal energy between the two or more substances are equal in nature. So it is that type of equilibrium where the thermal energy, okay, where the thermal energy between two or more substances do thermal energy in idella, that all will be equal in nature. That all will be equal in the form of a nature. Clear? So you'll note your example to heat flow ಹೇಗೆ ಆಗ್ತಿದೆ ಅನ್ನೋದು. So this is a where we are actually applying a temperature. Now according to the if in case you are not applying according to the surrounding area, so adರಲ್ಲಿ ನೋಡಿದ್ರೆ it is becoming reducing. Means what? Temperature is reducing. Clear? So here the heat flow is happening in this way. Understanding what is actually I'm trying to tell you people, what is the meaning of an thermal equilibrium? Clear? Everyone? Yes. So thermal equilibrium, they know it is a type of an equilibrium where between two or more substances are equal in nature. In nature, two or more substances will be equal in nature. Those all things are called as thermal equilibrium. Clear? Let's move to the next part, that is physical equilibrium. ಏನಪ್ಪ physical equilibrium? The type of equilibrium which develops between different phases and there is no change in chemical composition. There will be no change in the chemical composition. Chemical composition ಅಂದ್ರೆ ಏನು? ಈಗ ಏನೋ ಒಂದು ಪ್ರಿಪೇರ್ ಮಾಡ್ತಿದ್ದೇವೆ. Okay, we are preparing some things. So ಅಲ್ಲಿ composition ಇರಬೇಕು. ಯಾವ ತರ composition ಇರಬೇಕು? It should be liquid, gas, ಏನ್ ಹಾಕ್ತಿದ್ದೇವೆ, ಏನ್ ಬಿಡ್ತಿದ್ದೇವೆ, ಅದೆಲ್ಲ important ಇರುತ್ತೆ. Clear? So that's what the type of our equilibrium which develops between different phases and there is no change in chemical composition. Chemical composition ನಲ್ಲಿ ಏನು changes ಇರಲ್ಲ. Clear? In physical equilibrium there is the existence of same substances in a different physical state. In a different physical state they will be having a existence. So ಈ physical state different ಇದ್ರೆ ಏನಾಗುತ್ತೆ? ಒಂದ್ಸಲ ನಾವು ಯಾವುದೋ ಒಂದು ಲಿಕ್ವಿಡ್ ತಗೋದೇವೆ, ಅದರಲ್ಲಿ ಸೊಲ್ಯೂಟ್ ಏನು ಹಾಕ್ತಿದ್ದೇವೆ, we are adding a solute as a solid. So ಅವೆರಡು ಮಿಕ್ಸ್ ಆಗುತ್ತಲ್ಲ, physical state different ಇದೆ, right? Physical equilibrium means what? Both the things will be staying same. Okay, both the things are same, but state might be physical state might be different. Like we both are a twin. ಈಗ ನೀವು ತಿಳ್ಕೊಳ್ಳಿ, ನಂದು ಒಂದು ಟ್ವಿನ್ ಇದೆಪ್ಪ. ಓಕೆ, ನಂದು ಟ್ವಿನ್ ಏನಿದೆ ಅಲ್ಲ, ಇಬ್ರು ಟ್ವಿನ್ಸ್ ಇದಾವೆ. ವಿ ಬೋತ್ ಆರ್ ಟ್ವಿನ್ಸ್. ಓಕೆ, ಆದ್ರೆ ನಾನು ಜಾಸ್ತಿ ಫ್ಯಾಟ್ ಇದ್ದೇನೆ, ಅವಳು ಜಾಸ್ತಿ ಸ್ವಲ್ಪ ಸ್ಲಿಮ್ ಅದಾಳೆ. ಸೊ ದಟ್ ಇಸ್ ವಾಟ್ ಡಿಫರೆನ್ಸ್ ವಿಲ್ ಟೆಲ್. ಓಕೆ, how the difference is. So first let us learn according to the physical states itself how the equilibrium is gonna work. Okay, solid liquid equilibrium. Solid liquid equilibrium, just now I took the example. Let's see how it's working out. So H2O, which is in the solid state, which we are actually converting into the liquid. Like example, what? Ice only you take. Okay, freezing water they have given, ice only. So ನೀರು ತಗೋತಾರ, ಫ್ರಿಜ್ ನಲ್ಲಿ ಇಡ್ತಾರ, ರೈಟ್? ಫ್ರಿಜ್ ನಲ್ಲಿ ಇಡ್ತಾರ, ಅದು ಗಟ್ಟಿ ಆಗುತ್ತೆ, ಅವಾಗ ಸಾಲಿಡ್ ಅಂತ ಕರೀತಾರ. ಆಮೇಲೆ ರೂಮ್ ಟೆಂಪರೇಚರ್ ತೆಗೆದ್ಬಿಟ್ರೆ ಅದನ್ನ ಏನಾಗುತ್ತೆ, ಅದು ಮತ್ತೆ ಲಿಕ್ವಿಡ್ ಆಗುತ್ತೆ, ರೈಟ್? ಮೀನ್ಸ್ ವಾಟ್? ಇಟ್ ಇಸ್ ಅ ರಿವರ್ಸಿಬಲ್ ಪ್ರೊಸೆಸ್. ಪ್ಲಸ್ there is a change in the physical state. There is a change in the physical state. Clear? Next comes liquid vapor equilibrium. Liquid vapor equilibrium. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ liquid vapor equilibrium ನಲ್ಲಿ rate of vaporization is actually equal to rate of condensation. Rate of vaporization. Vaporization ಏನಾಗುತ್ತಲ್ಲ ಅದರದು ಮತ್ತೆ condensation ದು ಎರಡು ಸೇಮ್ ಇರುತ್ತೆ. Vaporization and condensation process will be rate will be same. Clear? Those all will be included in the liquid vapor equilibrium. Clear? ಈಗ ತಿಳ್ಕೊಳ್ಳಿ H2O liquid which is in a liquid form. Clear? And ಅದು ಕನ್ವರ್ಟ್ ಆಗಿದೆ ಯಾವಾಗ ಟೆಂಪರೇಚರ್ ಅಪ್ಲೈ ಮಾಡಿದ ತಕ್ಷಣ ವೇಪರ್ ಫಾರ್ಮ್ ನಲ್ಲಿ. ಕ್ಲಿಯರ್? ಈ ಲಿಕ್ವಿಡ್ ನಲ್ಲಿ ಏನಿರುತ್ತಲ್ಲ ಕನ್ವರ್ಟ್ ಆಗಿದೆ ವೇಪರ್ ಫಾರ್ಮ್ ನಲ್ಲಿ. ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಎರಡತ್ರದ್ದು ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಸೇಮ್ ಇದೆ. equilibrium same ಇದೆ. ಆಮೇಲೆ ಏನಾಗುತ್ತೆ, if it is a closed container, vapors will go and attach at the upper end of the plate and again it will get converted into the liquid. Again it will get converted into the liquid in this way. Okay, I have taken a vessel here. Clear? So I have taken a vessel here. I have added a water to it. I have applied a temperature to this. Okay, I have applied a temperature to this. Now what is going to happen? What is going to happen is this is a closed container. When you add a temperature to this, the vapors will go and settle at there. So vapors will go and settle at there and then it will go and convert. Again it will come down. ಯಾಕಂದ್ರೆ ಹೊರಗೆ ಹೋಗ್ಲಿಕ್ಕೆ ಏನು ಜಾಗನೇ ಇಲ್ಲ ಅಂದಮೇಲೆ this will come again and fall into the vessel itself. ನೀರಿನಲ್ಲಿನೇ ಬಂದು ಬೀಳುತ್ತೆ. ಕ್ಲಿಯರಾ? ನೀರಿನಲ್ಲಿನೇ ಬಂದು ಬೀಳುತ್ತೆ. This much you remember enough. Clear? Next, one second. Yes, clear with the liquid vapor. Next comes the conditions necessary for a liquid vapor equilibrium. What are the conditions for the necessity of the liquid vapor equilibrium? First comes what? The system must be closed system. The system must be closed system. That's what I told you in a previous one, right? So previous one is the closed container. This is a closed container. Right? Next. One second. Yes. Second point is the system must be at the constant temperature. Yes, whatever you have applied the temperature here, that should be constant. That should be constant. Clear? Next comes what? Yes. Third point is the visible properties of the system should be not changed with the time. The visible properties means these all properties which are present, no? These properties should be visible. Properties should be visible. Clear? Next comes what? Solid vapor equilibrium. Next topic is solid vapor equilibrium. Clear? So certain solid substances on heating get converted directly into the vapor without passing through the liquid phase. Okay. So certain solid substances is there. Okay. ಸ್ವಲ್ಪ solid substances ಇದೆ. ಆ solid substances ಯಾವಾಗ ನಾವು heat ಮಾಡ್ತೇವಲ್ಲ, that get converted. That will get converted directly. Clear? That will get converted directly into vapor without passing through the liquid phase. Without passing through the liquid phase. Like what? See now what is actually happening is ಸ್ವಲ್ಪ solid substances ಇರುತ್ತೆ. Okay. ಅವಕ್ಕೆ ಏನಾಗುತ್ತೆ, ನಾವು ಯಾವಾಗ heat apply ಮಾಡ್ತೇವಲ್ಲ, ಅವು convert ಆಗುತ್ತೆ directly into the vapor. Okay. ಯಾವಾಗ solid substance ಅನ್ನ heat ಮಾಡ್ಲಿಕ್ಕೆ start ಮಾಡ್ತೇವೆ. Like example I'll tell you. Any solid substances like any example right now I'm remembering, I can tell you in a daily life which is happening. Okay, ಕಲ್ಸಕ್ರಿ ಗೊತ್ತಾ ಎಲ್ಲರಿಗೂ? ಕಲ್ಸಕ್ರಿ ಶುಗರ್ದು ಹಾರ್ಡ್ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಇರ್ತಾರೆ, ಕಲ್ಸಕ್ರಿ. ಸೊ ಆ ಕಲ್ಸಕ್ರಿ ತಗೊಂಡು ಒಂದು ಬೋಗಾನಿಯಲ್ಲಿ ಹಾಕಿದ ತಕ್ಷಣ ಹೀಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ, that will convert into the liquid form. Okay, that will convert into the liquid form. Okay, convert directly into the vapor. Okay, ಇದು ವೇಪರ್ ಇರಲ್ಲ. So you can take naphthalene balls itself. Best option is naphthalene ball itself. ಯಾವಾಗ ಅದು ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ನಲ್ಲಿ ಇರುತ್ತಲ್ಲ, ಡೈರೆಕ್ಟ್ಲಿ the gaseous ನಲ್ಲಿನೇ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. Like sometimes it will be converted in the form of vapors also. Okay, so vapor without passing through the liquid phase. That's what I told you. Liquid phase ನಲ್ಲಿ ಹೋಗಲ್ಲ, ಡೈರೆಕ್ಟ್ vapor phase ನಲ್ಲಿನೇ ಹೋಗ್ಬಿಡುತ್ತೆ. Clear? And it's called as what? Sublimation. It's called as sublimation. So the vapor when cooled gives back the solid. It is called as deposition or desublimation or sublimation. Clear? Deposition, or it is also called as sublimation or desublimation or sublimation. Clear? Next example we can take easy one, that is NH4Cl, which is in the solid state in the presence of heating. Means we are applying a heat to that substances for NH4Cl. So that is getting converted into NH4Cl vapor state. NH4Cl vapor state. Clear? Example, ammonium chloride when heated sublimise. Ammonium chloride when we are going to heat it up, that is going to be, that will sublimise. That will sublimise. Clear till here everyone? Understood? Understood everyone? Yes, let's go to the next part. That is going to be equilibrium between solid and its solution. Equilibrium between the solid and its solution. These concepts are very, very important for the NEET purpose. Make sure you will read everything, whatever I am saying it, because you will ಅಷ್ಟೇ ಓದಿದ್ರು ಆರಾಮಾಗಿ PYQ solve ಮಾಡಲಿಕ್ಕೆ easy ಆಗುತ್ತೆ. Clear? So let's start. If a solid solute is in contact with the saturated solution, okay, ಯಾವಾಗ solid solute ಅಂದ್ರೆ solute ಯಾವಾಗಲೂ ಕಡಿಮೆ ಇರುತ್ತೆ, right? Solute ಯಾವಾಗಲೂ ಕಡಿಮೆ ಇರುತ್ತೆ. Now which is the solid which is in the form of a solid? Okay, which is in the form of a solid. This is less than the solvent, Okay, now what happens, this thing, what is there, contact with the saturated solution, there exists a dynamic equilibrium between the solid and the solution phase. Solid and the solution phase. Clear? Next comes what, solid substances which it can go, or it can be, means it can be reversible process, that is solution of a substances. Solid substances, it can be reversed back to the solution of a substances. Example, best example which we can give it, example, sugar and sugar solution. Sugar matte sugar solution, best example for a saturated solution. In a saturated solution, a dynamic equilibrium is been established between the dissolved sugar and a solid sugar. Between the dissolved sugar and a solid sugar. Clear? So this sugar which is in the form of a solid is going to be increasing with reversible process. It will be reversible process where that sugar can be converted to the aqueous medium, and that aqueous medium again can be converted to the solid form. Okay. So rate of this dissociation of solid sugar, rate of precipitation of the sugar from the solution. So at an equilibrium state, the number of sugar molecules going into the solution from the solid sugar is equal to the number of the molecules precipitating out from the solution, that is at equilibrium. So this is how the rate of the dissolution, this solution is gonna happen. Clear? So yavaga equilibrium between the solid and its solution is happening, you need to remember that it will be always be in a saturated solution itself. Means what? It exists a dynamic equilibrium. Clear? Done, done, done. Understood? Yes, let's move to the next part. Equilibrium between a gas and its solution in a liquid. So equilibrium between a gas and its liquid, its solution in liquid. So gases mixed in a liquids, the development factors for the solubility of the gas in any liquid are. So what are the developments? What are the developments which factors can apply for the solubility of a gas in any of the liquid? Okay. First comes what? Nature of the gas and the liquid. First comes what? Nature of the gas and the liquid, temperature of the liquid, pressure of the gas over the surface of the solution, pressure of the gas over the surface of the solution. Done. So first is the nature of a gas and a liquid. So first explanation ಏನಪ್ಪ. So ಯಾವ nature ಇದೆ gas ದು? Okay, ಆ nature what is the nature of that gas? Whether it is a smelling, whether it is a sticky, that also matters a lot. Okay, and what type of a liquid you have taken? What is the nature of that liquid is? That is also very, very important. Now temperature of the liquid, yes, that ಯಾವ temperature liquid ತಗೊಂಡಿರ್ತಲ್ಲ ಅದರದ್ದು temperature ಎಷ್ಟಿದೆಯಪ್ಪ? ಅದರದ್ದು temperature ಎಷ್ಟಿದೆ? How much is temperature? That is also important. Next, the pressure of the gas over the surface of the solution. See now, ಯಾವುದೇ pressure ತಗೊಂಡಿದಾರಲ್ಲ, ಈ gas ತಗೊಂಡಿದ್ದಾರೆ, ಆ gas ಎಷ್ಟಪ್ಪ pressure ಇದೆ surface area ಮೇಲೆ. ಈಗ ಏನಾದರೂ ಒಂದು ಬಾಯ್ಲ್ ಮಾಡ್ತಿದ್ದಾರೆ, temperature apply ಮಾಡ್ತಿದ್ದಾರೆ ಅಂದ್ರೆ surface ದಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, ಕೆಳಗಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. First the surface will start heating, you might see the bubbles at the first layer of the surface of the, but temperature has been applied from the down, guys. Temperature has been applied. That's what. There is a lots of difference between what type of a liquid you are taking it. Clear? So normal agi ನೀರು ತಗೊಂಡು ವೆಸೆಲ್ ನಲ್ಲಿ ಬಾಯ್ಲ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರೆ. ಕ್ಲಿಯರ್? ಸೊ ನೀರಿನಲ್ಲಿ ಬಾಯ್ಲ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ ತಕ್ಷಣ ಟೆಂಪರೇಚರ್ ತಳಗಡೆ ಫಸ್ಟ್ ಬಿಸಿ ಆಗುತ್ತೆ. ನೀರು ಯಾವಾಗ್ಲೂ ತಳಗ್ ಬಿಸಿ ಆಗಿರುತ್ತೆ, ಆಮೇಲೆ ಮೇಲಷ್ಟು ಬಿಸಿ ಆಗಿರಂಗಿಲ್ಲ. ತಿಳಿತಾ? ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ನಿಮ್ಮ ಮಮ್ಮಿ ಹೇಳ್ತಿರ್ಬೇಕು, ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಇಡು, ಚೆನ್ನಾಗಿ ಬಿಸಿ ಆಗ್ತದೆ ಎಲ್ಲ ಕಡೆ ಅನ್ನೋದು. ರೈಟ್? ಸೊ ಸೇಮ್ ಅದೇ ತರ ಇದು ಇಲ್ಲೂ ಅದು ಆಗೋದು. ಯಾವಾಗ ಆಗುತ್ತದು? ನೀ ಯಾವ ಟೈಪ್ ಆಫ್ ಲಿಕ್ವಿಡ್ ತಗೊಂಡಿದೆಯಲ್ಲ ಅದ್ರ ಮೇಲೆ ಎಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಅಪ್ಲೈ ಆಗ್ತಿದೆ, ಯಾವ ತರ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಆಗ್ತಿದೆ ಅನ್ನೋದು ಗೊತ್ತಾಗೋದು. ಸೊ ಓನ್ಲಿ ಐ ಸೆಡ್ ನೇಚರ್ ಆಫ್ ದ ಗ್ಯಾಸ್ ಅಂಡ್ ದ ಲಿಕ್ವಿಡ್ ಇಸ್ ವೆರಿ, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. Clear? Next, this equilibrium is defined by Henry's law, which explains that the mass of the gas is mixed, which explains that the mass of the gas is being mixed is known as mass of the solvent at a temperature. Mass of the solvent at a temperature. So is proportional to the solvent's pressure. It's proportional to the solvent's pressure of the given gas, and it decreases with increase of temperature. It decreases with increase of the temperature. It is getting decreased with the increase of the temperature. Clear? So it is very, very important. E concept bada important ಇದೆ. according to the Henry's constant, how it's been applying. Okay, whenever the mass of the gas has been mixed, the mass of the solvent at that temperature, ಎಷ್ಟು mass ಇದೆ solvent ದು ಆ solution ಅಲ್ಲಿ solvent ಎಷ್ಟು mass ಇದೆ ಆಯ್ತಾ. So and is proportional to the solvent's pressure. solvent's pressure ಎಷ್ಟಿದೆ. First ಏನು mass of the solute, mass of the solvent ಎಷ್ಟಿದೆ, ಮತ್ತು ಅದರದ್ದು is directly, that is directly, I'll write it down here. One second. Mass of the solvent at a temperature is proportional to the solvent's pressure of the given gas. Solvent's pressure, okay. Solvents ದು ಎಷ್ಟು ಪ್ರೆಷರ್ ಇದೆ given gas ದಲ್ಲಿ, okay, ಯಾವ ತರನು ಗ್ಯಾಸ್ ಹೊಂದಿರ್ತಾರಲ್ಲ, ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದಟ್. ಓಕೆ, ಸೊ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದ ಸಾಲ್ವೆಂಟ್ಸ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಗಿವನ್ ಗ್ಯಾಸ್, ಸೊ ಇಟ್ ಡಿಕ್ರೀಸಸ್ ವಿತ್ increasing in temperature. So what happens because of this? So because of this only, it is decreasing with increase in the temperature. Decreasing with increase in the temperature. Clear? ತಿಳಿತಾ ಎಲ್ಲರಿಗೂ Henry's law ಅಂದ್ರೆ ಏನು? This is important, guys. Don't forget to practice this question. Okay? ಹಾಕಿದೇನಾ ಆಲ್ರೆಡಿ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ? ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ಯು ಕ್ಯಾನ್ ರಿಮೆಂಬರ್ ಈಸಿಯೆಸ್ಟ್ ವೇ ಯಾವ್ದು ಪ್ರಪೋರ್ಷನಾಲಿಟಿ ಎಲ್ಲಿದೆ ಅನ್ನೋದು. ಸೊ ಮಾಸ್ ಆಫ್ ದ ಸಾಲ್ವೆಂಟ್ ಇದೆ, ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಇದೆಯಲ್ಲ ಅದು ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಆಗುತ್ತೆ ಸಾಲ್ವೆಂಟ್ಸ್ ದು ಪ್ರೆಷರ್ ಆಫ್ ದ ಗಿವೆನ್ ಗ್ಯಾಸ್. ಡನ್? ಎಸ್, ನೌ ಲೆಟ್ಸ್ ಮೂವ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್. ದಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ chemical equilibrium. Now one second. Yes, so in a chemical equilibrium, concentration of the reactants and the products do not change with the time and the system does not show any further changes in the properties. So for that purpose, in case of a chemical equilibrium, rate of a forward reactions become equal to the rate of the backward reactions. So ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? rate of a okay, rate of a backward reaction, that is rate of a forward reaction, is equal. Okay, rate of a backward reaction is actually equal to the rate of a forward reaction. So backward forward full confusion nodili. So rate of a backward reaction is actually, that is a rate is directly proportional or equal to the rate reaction, is actually directly equal to the rate reaction. Done? So forward reaction in an open glass container is what? 3Fe is getting reacted with water. Concentrate iron is there. Iron which is in the form of a solid is getting reacted with the gaseous form of a water. Means what? Moisture is morning time dalli. So aವಾಗ ಏನಾಗ್ತಿದೆ? iron ಹೋಗಿ ರಿಯಾಕ್ಟ್ ಆಗ್ತಿದೆ ನೀರ್ ಜೊತೆ, ಮೀನ್ಸ್ ಮಾಯಿಶ್ಚರ್ ಗ್ಯಾಸ್ ಜೊತೆ. ಓಕೆ, ಅವಾಗ ಏನ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ? 3Fe plus 4H2O is formed. Clear? So in the container tube is closed, both the reactions take place simultaneously and hence the reactions becomes reversible process. So ಯಾವಾಗ ಆಗುತ್ತೆ ಈ ರಿಯಾಕ್ಷನ್? ಯಾವಾಗ ರಿವರ್ಸಿಬಲ್ ಪ್ರೊಸೆಸ್ ಆಗುತ್ತೆ? when the container tube is being closed. Like example, iron vessel ಇದೆ ತಿಳ್ಕೊಳ್ಳಿ. Okay, that iron vessel which is present, you have kept it in the humid condition. So ಯಾವ್ದಾದ್ರು ಒಂದು ಬಿಸಿಲು ಏರಿಯಾದಲ್ಲಿ ಹಾಕಿಡ್ತಾರೆ ಅದನ್ನ ಐರನ್ ಬಾಕ್ಸ್ ಅನ್ನ. ಸೊ ಒನ್ಸ್ ದಟ್ ಐರನ್ ಬಾಕ್ಸ್ ಹಸ್ ಬೀನ್ ಗಿವನ್, ಆ ಐರನ್ ಬಾಕ್ಸ್ ಏನ್ ಕೊಟ್ಟಿರ್ತಾರಲ್ಲ, ಸೊ ಅವಾಗ ಫುಲ್ ಅರೌಂಡ್ ಸರೌಂಡಿಂಗ್ ಟೆಂಪರೇಚರ್ ಇಂದ ಅದು ಒಂಥರ ಮಾಯಿಶ್ಚರ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಓಕೆ, ಇಟ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಗೆಟಿಂಗ್ ಸರೌಂಡಿಂಗ್ ದಿಂದ ಎಲ್ಲ ಹೀಟ್ ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೊಂಡು ಮಾಯಿಶ್ಚರ್ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ? ದಟ್ ವಿಲ್ ಬಿ ಆಕ್ಚುಲಿ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಅ ಗ್ಯಾಸ್. ಅದು ಫಾರ್ಮ್ ಆಫ್ ಅ ಗ್ಯಾಸ್ ನಲ್ಲಿ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಅವಾಗ ದಟ್ ಥಿಂಗ್ ವೆನ್ ಇಟ್ ಇಸ್ ಇನ್ ದ ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್ ದಿಸ್ ವಿಲ್ ಹ್ಯಾಪನ್ ಅ ರಿವರ್ಸಿಬಲ್ ರಿಯಾಕ್ಷನ್. ಕ್ಲಿಯರ್? ಸೊ ಈ ತರ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ. 3Fe when it is getting reacted with a gaseous form of a water, we will get Fe3O4 plus H2. Fe3O4 plus 4H2. Clear everyone? ಸೊ ಯಾವ ತರ ಕ್ಲೋಸ್ಡ್ ಕಂಟೈನರ್ ನಲ್ಲಿ ಹೇಗಾಗುತ್ತೆ, ಓಪನ್ ಕಂಟೈನರ್ ನಲ್ಲಿ ಹೇಗಾಗುತ್ತೆ ಅನ್ನೋದು ಕ್ಲಿಯರ್ ಆಯ್ತಾ? ಡನ್. Next comes the characteristics of equilibrium state. So what are the characteristics of equilibrium state? So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಫಸ್ಟ್ the reaction or a process is said to be equilibrium when the rate of the forward reaction becomes equal to the rate of backward reaction. Clear? So ಯಾವಾಗ ರಿಯಾಕ್ಷನ್ equilibrium ಅಂತ ಹೇಳ್ತಾರೆ, ಬ್ಯಾಕ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಮತ್ತೆ ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಎರಡು ಫುಲ್ ಕಂಪ್ಲೀಟ್ಲಿ ಈಕ್ವಲ್ ಇದ್ದಾಗ ಅವಾಗ ಇಟ್ ಈಸ್ ಆಕ್ಚುಲಿ ಇನ್ ದ equilibrium state ಅಂತ ಕರೀತಾರೆ. ದೆನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಗೈಸ್? ತಿಳಿತಿದೆನಾ? ಓ ತಿಳಿತಿದೆ, ನೈಸ್. ಓಕೆ, next point ಹೋಗೋಣ. An equilibrium is a dynamic in nature and not static. That is, even after the equilibrium is being attended, the forward as well as the backward reaction takes place, but at a equal speed. So because even though an equilibrium is a dynamic in nature and it is very static means what? Everywhere it is will be in a josh way. Okay, so ನಾನು ಹೋಗಿ ನಿನಗೆ ಬಡಿಬಹುದು, always it will be in a very active mode. Okay, ನಿಮ್ಮ ಸ್ಕೂಲ್ ನಿಮ್ಮ ಕಾಲೇಜ್ ನಲ್ಲಿ ನೋಡ್ರಿ ಬೇಕು, ಸ್ವಲ್ಪ ಹುಡುಗರು ಇರ್ತಾರೆ ಹೂ ವಿಲ್ ಬಿ ಆಲ್ವೇಸ್ ಬಿನ್ ಆಕ್ಟಿವ್ ಮೋಡ್. ಸೊ ನಾನು ಇದನ್ನ ಮಾಡ್ತೇನೆ, ಅದನ್ನ ಮಾಡ್ತೇನೆ, ಅಲ್ಲಿ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡ್ತೇನೆ, ಐ ವಿಲ್ ರೈಟ್ ನೀಟ್ ಆಲ್ಸೋ, ಐ ವಿಲ್ ರೈಟ್ JEE ಆಲ್ಸೋ, ಐ ವಿಲ್ ರೈಟ್ KCET ಆಲ್ಸೋ, ಐ ವಿಲ್ ರೈಟ್ ಆಲ್ ದ ಯೂನಿವರ್ಸಿಟೀಸ್ ಆಲ್ಸೋ. ಸೊ ಈ ತರ ಹುಡುಗರು ಇರುತ್ತಾರೆ, ರೈಟ್? ಸೊ ಆ ಹುಡುಗರಿಗೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ನಲ್ಲಿದೆ ಅಂತ ಹೇಳ್ಬಹುದು ನಾವು. ಬಟ್ ವಿ ಹ್ಯಾವ್ ಅ ಕಂಡೀಷನ್ ಹಿಯರ್. ಓಕೆ, ಸೊ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಎಲ್ಲ ಬ್ಯಾಕ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಮತ್ತೆ ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಎರಡು ಈಕ್ವಲ್ ಇರುತ್ತೆ, ಐ ಅಗ್ರಿ. ಬಟ್ ದೋಸ್ ಆಲ್ ಥಿಂಗ್ಸ್ ವಿಲ್ ಬಿ ಹ್ಯಾಪನಿಂಗ್ ಅಟ್ ಅ ಈಕ್ವಲ್ ಸ್ಪೀಡ್. ಓಕೆ, ಈಕ್ವಲ್ ಸ್ಪೀಡ್ ನಲ್ಲಿ ಆಗ್ತಿರುತ್ತೆ. ಒಂದ್ ಹುಡುಗ ಇರ್ತಾನೆ, ಇಲ್ಲ ಒಂದ್ ಸ್ಟೂಡೆಂಟ್ ವಿಲ್ ಬಿ ದೇರ್ who is getting ready for JEE also at the equal speed, who is getting ready for NEET also at at the correct speed, and who is getting ready for the KCET also at the correct speed. Means what? Equal speed ನಲ್ಲಿ ಆ ಮನುಷ್ಯ ಮೂರುದ್ರನ್ನ ಮಾಡ್ತಿದ್ದಾನೆ. That's how the equilibrium works. Clear? So a chemical equilibrium can be established only if none of the products is allowed to escape out. So when the chemical equilibrium is going to be done properly, so can be estimated only if none of the products is allowed to escape out. So ಏನಾದ್ರೂ equilibrium constant ಆಗ್ತಿದೆಯಪ್ಪ, ಓಕೆ, equilibrium state ನಲ್ಲಿ ಬರ್ತಿದೆ. So ಯಾವಾಗ ಆಗುತ್ತೆ? when it is actually the whatever solution is there in that container, that should be not escaped out, not even little bit. ಸ್ವಲ್ಪನೂ ಆದ್ರೆ there will be a changes in the speed, there will be a changes in the temperature, there will be changes in the surface tension, there will be a changes in the pressure. So for that purpose, whatever it's happening, it should be inside, it should not escape out of the container. Clear? That is about the equilibrium state. So at equilibrium, the concentration of each of the reactant constant becomes constant. Means what? Reactant and product will always be constant way. Okay, means what? ATP, strong constant ATP, and it will be constant STP. Means standard temperature, pressure, and ATM pressure. Okay, so here graph ಕೊಟ್ಟಿದ್ದಾರೆ which is actually a concentration versus temperature. You can just check it out how the temperature has been working here. So forward ಮತ್ತೆ backward reaction ಅಲ್ಲಿ ಹೇಗೆ ವರ್ಕ್ ಆಗ್ತಿದೆ ನೋಡಿ, ಈಕ್ವಲ್ ಇರುತ್ತೆ, ಯಾವಾಗಲೂ ಈಕ್ವಲ್ ಇರುತ್ತೆ. See, forward reaction is always equal to backward reaction. Clear? So ಇಲ್ಲಿ concentration versus time ನಲ್ಲಿನೂ ಅದೇ ಆಗ್ತಿದೆ, it is the equilibrium. So ಏನಾಗುತ್ತೆ, A or B solution ನಲ್ಲಿ same concentration ಯಾವಾಗ ಡಿಕ್ರೀಸ್ ಆಕೊಂತ ಹೋಗುತ್ತಲ್ಲ, time will also decrease and it becomes constant. When you are applying it to constant temperature, concentration ಮತ್ತೆ time apply ಮಾಡ್ತಾರಲ್ಲ, ಅವಾಗ ಇದು constant ಆಕೊಂತ ಹೋಗುತ್ತೆ, it will become constant itself. Same is happening to the same at the product side also. Okay, reactant ಮತ್ತೆ products ಅಲ್ಲಿ ಸೇಮ್ ಆಗ್ತಿದೆ, that will be continued like this only. ಯಾಕೆ? because we are learning it in the form of equilibrium. ಮತ್ತೆ ಈಗ ನಾವು equilibrium ಅಂದ್ರೆ ಏನು, ಕಾನ್ಸ್ಟೆಂಟ್ ಟೆಂಪರೇಚರ್ ಹಾಕಿದ್ದೇವೆ, ಟೆಂಪರೇಚರ್ ಪ್ರೆಷರ್ ಹಾಕಿದ್ದೇವೆ, ಸೊ ಅವೆಲ್ಲ ಈಕ್ವಲ್ ಇದೆ ಅಂದಮೇಲೆ ಅದೇನು ವರ್ಕ್ ಆಗ್ತಿದೆ ಅಲ್ಲ ಅದು ಈಕ್ವಲ್ ಇರೋದಲ್ಲ. So that is what I wanted to tell you, and that is what the graph is also telling. Clear? Done? Understood till here? Yes, let me have a little bit of water. Yes, I'm audible now. Okay. So this is clear. This is clear. Next comes when reaction attains an equilibrium at certain temperature, pressure, delta G is going to be the 0. So, yavaga equilibrium iruttalla at certain temperature and pressure. Means what? Naniga 289 Kelvin hakidenappa. Temperature eshtu hakidene? I have applied 298 Kelvin of temperature and 1 atm pressure. Okay. Temperature is this much and I have applied pressure this much. Clear? Now you should remember one more thing here. One more thing you should remember. In this, whatever it is happening, in this, whatever this both the things are happening, temperature and pressure, ಎರಡು ಕಡೆ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡು ಮತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ಸೈಡು ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡು ಮತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ಸೈಡು ಎರಡು ಕಡೆ ಸೇಮ್ ಥಿಂಗ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು and continuously you need to be the same constant. Clear? That time delta G is going to be the 0. That time the delta G is going to be the 0. Clear? So the chemical equilibrium can be achieved from the either direction. So now next comes the law of mass action. This is also very important, guys. So in PU board also it's very much important first year students. So idu bala important is the first year PUC students ge. So because I know your college teachers only will prepare your papers. ಸ್ವಲ್ಪ ಮಸ್ಕ ಹಚ್ಚಿದ್ರೆ ಮ್ಯಾಮ್ ಪಾಸ್ ಮಾಡ್ತಾರೆ ಬಿಡಿ. ಪಾಸ್ ಮಾಡ್ತಾರಪ್ಪ ಕುಂತು ಓದಿದ್ರೇನೆ ಮುಂದಿನ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ ಸೈನ್ಸ್ ಅಷ್ಟೇ ಮಾಡಿ ಏನು ಮಾಡೋದಿರಿ ನಾ? Right? What you people will do doing just the science? You need to write the competitive exams. ನೀವು competitive exams ಬರೀತಿಲ್ಲ ಅಂದ್ರೆ science is just waste. You need to write KCET at least. You need to write at least NEET or a JEE. So if you didn't write this all things, it's just waste for you people. Right? So ಏನು ಮಾಡೋದು PUC ಮಾಡಿ ಮತ್ತೆ? Right? So ಅದರ ಸಲುವಾಗಿ ಹೇಳೋದು if you people are concentrated much on the concept understanding, PYQs ಆರಾಮಾಗಿ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ಬೋದು. ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ನೀವು ಅದನ್ನು ಬರೇ ಮ್ಯಾಮ್ ತೆರಿನ ಕುಂತ ಅಂತ ಮಾಡಬೇಡಿ. PYQs ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. ಯು ನೀಡ್ ಟು ಹ್ಯಾವ್ ಅ ಐಡಿಯಾ ದಟ್ ಯಾವ ಥರ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ ಅನ್ನೋದು. ಓಕೆ, ಯಾವ ಥರ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ ಅದು ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇರೋದು. ಕ್ಲಿಯರ್? ಓಕೆ ದೆನ್ ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದ ಕಾನ್ಸೆಪ್ಟ್. Law of mass action. So the rate of reaction is proportional to the product of the active masses. Whatever the rate of the reaction is there, that is actually proportional to the rate of reaction is actually proportional to the active masses of the reactants. So it's actually proportional to the active masses of the reactants. So reactants do ಎಷ್ಟು mass ಇದೆ ಅನ್ನೋದು ಅದರ ಮೇಲೆ react ಆಗುತ್ತೆ. It is very important that how much actually it is there. Clear? Next, active masses of the reactants, in which each term is raised to the power equal to its stoichiometric coefficient as represented by the balanced chemical equation. So for that purpose, rate of reaction is directly proportional to AB, BB, CC. Okay? AA, BB, CC. So whatever the rate of reaction is there, it will directly proportional to the active mass of the reactants. So ಯಾವ ತರ masses ಇದೆ reactant side ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ what might be the rate of the reaction. Simple example daily life ನಲ್ಲಿ ಹೇಳ್ತೇನೆ ಆಯ್ತಾ. So now you people, rate of the reaction will have a point here. So ಈ ಹೇಳಿದ್ನಿ actually ನಾನು rate of reaction ಇದೆ. Okay, rate of the reaction is directly proportional to the active masses of the reactants. active masses of the reactants. Now what you people need to do is, need to do is rate of the reaction yaudadru anta tagolona. Okay, rate of the, or else you will take the active masses. Okay, active masses yaudadru anta tagondidira. Now you are preparing. Okay, I have taken 1 kg of sugar. Okay, 1 kg of sugar ತಗೊಂಡಿದ್ದೇನೆ. Okay, ಆ 1 kg of sugar, ಅದರ mass ಎಷ್ಟಂತ ಗೊತ್ತಾಯ್ತು. Mass of the reactant is how much? 1 kg. So it's equal to, proportional to what? Rate of the reaction. Rate of the reaction ಅಂದ್ರೆ ಏನು? In case na ಇದರಲ್ಲಿ water ಹಾಕಿದ್ರೆ rate of the reaction what will happen? It will decrease. Right? So if in case I didn't add the water, the rate of the reaction what will happen? It will, increase. Clear? This much you people need to remember. Means what? Try to understand the concept in that way that you need to be, try to understand the concept in that way that you need to be very active and you need to compare the things with the real life examples so that it will stay in your mind. Okay, so ಯಾವ್ದಾದ್ರು ಹೇಳ್ತಿದ್ದೆ ಅಂದ್ರೆ ಏನಾದ್ರೂ ಎಕ್ಸ್ಪ್ಲನೇಷನ್, ಈಗ ನೀವೇ ಏನಾದ್ರು ಓದ್ತಿರ್ತೀರ, ನಿಮಗೆ ತಿಳಿತಪ್ಪ ಅದು, ಸೊ ಅದನ್ನು ಯಾವ್ದಾದ್ರು ಅಂದ್ರೆ ನಿಮ್ ರಿಯಲ್ ಲೈಫ್ ನಲ್ಲಿ ಕಂಪೇರ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ ಅದು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ. ಆಯ್ತಾ? So next, that is law of chemical equilibrium is a result obtained by applying the law of mass action to the reversible reaction in equilibrium. So A plus B is a reversible of C plus D. Next, rate of a forward reaction is directly proportional to AB. It's directly proportional to AB. So rate of backward reaction is directly proportional to CD. It's directly proportional to CD. Now, how you people can take a KF and KB now? Okay, KF means what? KF means what? Proportionality constant. KF means forward reaction. Rate of forward reactions. Clear? So what is the meaning of KB? KB is what? Rate of backward reactions. Rate of backward reactions. Clear? So this is how it's going to work. So at equilibrium, rate of forward reaction is actually equal to the rate of backward reaction. We already know that. Clear? So this you people need to know now, because we are going to learn the calculation on the basis of forward reaction and the backward reaction. Clear? Yes. Next, KF, that is a forward reaction AB is equal to the backward reaction of AB, means the reactant side, or it is can also be written in the form of CD divided by AB, CD divided by AD. KF divided by KB is actually equal to K. It is actually equal to K. Done? So at constant temperature, KF and KB are constant. Therefore, KF and KB is equal to K. So for that purpose only, in constant temperature idella, KF and KB idella are constant. Therefore, KF and KB is always equal to K. So therefore, for that purpose only, KF and KB is always equal to K, and is always constant at a temperature and is actually called as equilibrium constant. Adra salaga enanta karibohudu? Equilibrium constant antanu karibohudu. Equilibrium constant antanu karibohudu. So next, the product of the molar concentration of the products, each raised to the power equal to its stoichiometric coefficient. It's actually equal to its stoichiometric coefficient, where it is divided by the product of the molar concentration. Here it is actually divided by the molar concentration of the reactants of each raised to the power equal to its stoichiometric coefficient is constant at a constant temperature is called as equilibrium constant. So ಏನಂತ ಕರೀತಾರೆ equilibrium constant ಗೆ? I'll explain it once again. One second guys. Yes. So the product of the molar concentration. Molar concentration andre niಮಗೆ ಗೊತ್ತಿದೆ already. Molar concentration andre first chapter ನಲ್ಲಿ ಕಲ್ತಿರಬೇಕು ನೀವು already ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಅನ್ನೋದು, right? So of the product is each raised to the power equal to ಏನೇನ್ ಪವರ್ ಇದೆ ಅಲ್ಲ, ಏನೇ ಪವರ್ ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ Cl2, okay, whatever the power is there, okay, whatever the power is there is equal to its stoichiometric coefficient. ಅದರ coefficient ಏನಿದೆ ಅಲ್ಲ ಅದಕ್ಕೆ ಈಕ್ವಲ್ ಇರುತ್ತೆ. ಕ್ಲಿಯರಾ? ಆಮೇಲೆ divided by the product of the molar concentration. Molar concentration of that, okay, ಏತರದಿದೆ ಅಲ್ಲ ಅದರದ molar concentration, okay. Next of the reactants each raised to the power equal to its stoichiometric coefficient again. So that all constant, it happening in the constant temperature. ಎದರಲ್ಲಿ ಆಗ್ತಿದೆ ಇದು constant temperature ಅಲ್ಲಿನೇ ಆಗ್ತಿದೆ. For that purpose it is called as equilibrium constant. ಅದಕ್ಕೆ ಏನು ಕರೀತಾರೆ? Equilibrium constant ಅಂತ ಕರೀತಾರೆ. Clear? Next comes homogeneous equilibrium. What is the meaning of an homogeneous equilibrium? Clear? So when all the reactants and the products, are in the same phase. So products ಮತ್ತೆ reactants ಎಲ್ಲ same phase ನಲ್ಲಿದೆ. Phases are actually same. Clear? So same phases. For a homogeneous system, this phenomenon is termed as homogeneous equilibrium. ಏನಂತ ಕರೀತಾರೆ ಅದಕ್ಕೆ? Homogeneous equilibrium ಅಂತ ಕರೀತಾರೆ. So whenever all the reactant and the products are in the same phase, same phase for the homogeneous system, then this phenomenon is termed as a homogeneous equilibrium. For the example, in the gaseous reaction, you can give it as how? CaCO3, which is in the solid state, by heating it. You are heating the CaCO3. By heating it, you are going to get what? CaO, which is in the solid state, or CO2, which is in the gaseous state. Clear? So reactants and the products are in homogeneous phase itself. Similarly, for the reaction of this also, like CH3COO C2H5, which is in the aqueous medium, which is getting reacted with the liquid medium of H2O. Means what? Liquid gas ಇದೆ. Clear? So ಏನು ಫಾರ್ಮ್ ಆಗ್ತಿದೆ? aqueous medium ನಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತಿದೆ ಎರಡು. Done. Yes, homogeneous equilibrium is clear. One more example also they have given, you can go through it. Equilibrium constant in a gaseous reaction. What is actually the equilibrium constant in a gaseous reaction? Okay, so gaseous reaction nalli equilibrium constant hegide. Okay, clear? Understood till here everyone? ಹೇಗಿದೆ ಅನ್ನೋದು ನಾವು ಈಗ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ಲೆಟ್ಸ್ ಸಿ ಹೌ ಇಟ್ಸ್ ಇಸ್ ಆಕ್ಚುಲಿ ಹ್ಯಾಪನಿಂಗ್. So for gaseous reaction, equilibrium constant is expressed in the terms of partial pressure. So what happens in the gaseous reaction? ಈ ಎಲ್ಲಾ gaseous reaction ನಲ್ಲಿ ಏನೇನ್ equilibrium constant ಇದೆ ಅಲ್ಲ, that will be all experienced in the form of partial pressure. Partial pressure ಇಂದ form ಆಗುತ್ತೆ. P0 is also called as partial pressure. Okay. For example, ಏನು ತಗೋಬಹುದು? The decomposition of N2O2 into NO2 in closed container in a gaseous reaction at equilibrium. So decomposition ಆಗ್ತಿದೆ. Okay, decomposition of N2O2 decomposition ಆಗುತ್ತೆ into NO2. Okay, ಅವಾಗ ಏನಾಗುತ್ತೆ ಆ ರಿಯಾಕ್ಷನ್? It is all things are happening in the it is all happening in the closed container. ಇದೇನಾಗ್ತಿದೆ ಅಲ್ಲ, this all things are happening in a closed container. Okay, it's happening in the closed container. So at equilibrium, at chemical equilibrium. Okay, at chemical equilibrium. Clear? Next comes ideal gas equation for that. This all things are very, very important, guys. Ideal form of equation is very important. Ideal gas equation bala important ಇದೆ. ಅದನ್ನಂತೂ ನೀವು ನೋಡ್ಕೊಳ್ಬೇಕು. 100% sure question ಇದು, ಆಯ್ತಾ? Now, in ideal gas equation, PV is equal to nRT. What is PV is equal to nRT? I will explain it to you people, okay? So, PV is equal to nRT where if we want, okay, but pressure is to find P will be equal to N divided by nRT, just V will go this side. So, that will be what? P is equal to nRT divided by V. Clear? So, where P is going to act like a pressure of the gas in the bar, pressure of a gas in the bar, and N is equal to number of the moles of the gas in mole, number of the moles of the gas in the mole. Means what? Yes, number of moles ide a gaseous nalli. Means yav gas tagondidare, like example tagoli ಈಗ H2 gas ತಗೊಂಡಿದ್ದೀರಾ, ಆ H2 gas ನಲ್ಲಿ ಎಷ್ಟಪ್ಪ moles ಇದೆ, ಎಷ್ಟಪ್ಪ moles ಇದೆ. You know already how to find the moles. Next, V is equal to volume of the gas in the form of a liter. ಯಾವಾಗಲೂ liter ನಲ್ಲಿ ಇರಬೇಕದು. So in case liter ನಲ್ಲಿ ಇದೆ ಇರಲಿಲ್ಲ ಅಂದ್ರೆ you need to convert that into the liter. Clear? So T is equal to absolute temperature in the Kelvin, absolute temperature into the Kelvin, and R is equal to 0.0831 bar liter per mole per Kelvin. Okay? Per liter per Kelvin. Clear? This will be always be constant itself. ಇದು ಯಾವಾಗಲೂ constant ಇರುತ್ತೆ. Next, now form the equation like 1. This will let me the equation as a 1. Now P is equal to CRT, or it is also called as P is equal to gas into RT, where C is equal to N divided by V, where C is equal to N divided by V. So C ಅನ್ನು ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋದು, N divided by V ಅಂತ. ಇಲ್ಲಿ ಏನು N ಇದೆ ಅಲ್ಲ ಅದರದು. Here what N is there, no? So N ಇದೆ ಅಲ್ಲ ಅದು that is actually equal to what? C is equal to N into V. Done? I'm sorry. Next. Okay, N into V la N divided by V. ಅದೇ ಏನೋ ಆಗ್ತಿದೆ ಅಂತಿದೆ. Okay. Next, at constant temperature, pressure of the gas is proportional to its concentration. So whatever the constant temperature is there, that is actually pressure of that gas is actually proportional to the gas itself. So the pressure of the gas in the bar is directly proportional to the gas, how much they have taken it. Means what? Gas is very important. Now, eegadru ತಿಳಿತಲ್ಲ gas ಎದಕ್ಕೆ important ಇದೆ ಅನ್ನೋದು. Understood? Now why gas is important to everyone? Understood? Yes. Clear? Next, for general equation equilibrium, AA and BB gases is forming CC plus DD. Like example, KP, that is also called as a K means pressure of the gas here itself. So that is going to be what? PC divided by into DPD divided by PA into PB. Done? Idnu ನೆನಪಿಟ್ಕೋಬಹುದು. Means according to the equation, according to this above equation, this is the thing which is forming. Okay. Next, equilibrium constant in the terms of a mole fraction. Consider a general equation reaction in equilibrium where AA plus BB is actually a reversible reaction, that is CC plus DD, where amount of A is actually be XA, that is mole fraction of a A. That will be what? Mole fraction of a A. And amount of B is equal to what? XB, that is a mole fraction of a B. That will be what? Mole fraction of a B. Then amount of a C is equal to what? XC, that is mole fraction of a C, and D is XD, that will be mole fraction of a D. Means what? You need to find all mole and you need to completely divide it here. You need to completely divide it here. This much you remember, it's enough about the moles. Okay. Now, how you are going to find? Now, how you are going to find about the mole? I'll tell you. So, mass divided by molar mass will be how you are going to find the mole of it. Clear? I'll write it here. One solve reference salvagi. Okay, remember this thing, it will be easy to find it. Okay, next comes relationship between the Kc, Kp and Kx. So what is a Kp and Kc and Ks? So now Ks means, Kc means you people know already what is the meaning of Kc. This is how the Kc is going to come. then afterwards the Kp, and then the Kx according to the pressure, and according to the C, according to the X, that is mole fraction. According to those concentration, pressure and the mole fraction, we will find the relationship between them. Okay, the relationship channagi kunt nodkolona first. Aita? First is consider a general equation in the equilibrium. That is going to be, first we are going to do about the Kp and Kx. Okay. First you have to do Kp matte Kx do. So adra one reaction tagolodu AA plus BB, which is actually forming Cc plus Dd, right? Cc plus Dd, right? According to the Rolle's law, Pa is actually equal to Xa into P. Okay. Pa is actually equal to what? Xa into P. Pa matte Xa andre mole fraction, P andre pressure. Now where Pa is the partial pressure of a gas A, so yav gas tagondira in case H2 tagondidre PH2 antanu barkobodu to make you understand properly. Okay, solve madud munde easy agutta. So H2 and Pa is equal to partial pressure of a gas A, Xa is equal to mole fraction of a gas A, and P will be the total pressure. So P is the total pressure aitu. Okay. Next iga similarities enirate, Pb is actually equal to same ade tara. If you are going to find the compound of B, C, D, adnu hige barkobohudu. Like example, XBP into P, PC, XC into P, and XD into P. Done. So now how you are going to get the equation? Now Kp is equal to PCPD. This namage hindinda gottagide idrinda, right? So that is what we have written it here according to that pressure. Now what happens, the thing is here, whatever the mole fraction you are finding it. Now according to that, this is actually done. Partial pressure aitu, total pressure find madidvi papa of A, B, C, D, do ellatu pressure find madidvi. This will be what? This will be according to the equation what they have given. According to that, in case they have given H2, find the H2's mole fraction. How you will find moles? How you will find the moles of it? Moles is equal to mass divided by molar mass. So atradu yavyavadu component kottidare, like example A, B, C, D do yavyav components kottidaralla avtardella you need to find the moles. Number of moles find madbeku. Number of moles find madid takshana you will have an idea that how to find the total pressure of it. Clear? So total pressure ee tara find madkobohudu. Clear? So Kp is always equal to Kx P raised to delta n. P raised to delta n. This is also important. Okay. Kp is equal to what? Kp is equal to Kx into P delta n. P delta n. Done? Oh, no, 1 second guys. Yes. Huh? Done? Ulta square. Okay. Okay, now when n delta Ng is going to act like what? C plus D minus A plus B. So delta Ng enagutte C plus D minus A plus B. Clear? Next comes relationship between the Kp and Kc. Relationship between the Kp and Kc. Now consider a general equation. This is a general equation reaction in the equilibrium where AA and BB is actually forming Cc and Dd. Clear? So here what happens? P is actually equal to N divided by V into RT. N divided by V into RT. That will be equal to CRT. That will be equal to CRT. Clear? Where C is going to be what? Where C is going to be what? N matte V. So if equation namagu already gottide. Clear? Okay. ನಾವೀಗ ಏನು ಮಾಡ್ಕೋತಿದ್ದೇವೆ ಅಂದ್ರೆ ಇದು ಎನ್ ವಿ ಅನ್ನ ಕನ್ವರ್ಟ್ ಇಲ್ಲಿ ಬರೀತಿದ್ದೇವೆ. ಸೊ ದ ಪಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್? ಸಿ ಆರ್ ಟಿ ಆಗುತ್ತೆ. ಸೊ ವೆನ್ ಯು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ದಿಸ್ ಥಿಂಗ್. Done? Next, for an ideal A, PA is equal to CART. So in case you are going to find a ideal gas of a one component A. Okay, one component A and find ಮಾಡ್ತಿದ್ದೇವೆ. Done? So ಅವಾಗ ಏನಾಗುತ್ತೆ? Where PA is going to be the partial pressure of the gas A, where CA is going to be the concentration of that gas A, R is going to be the normal gas constant, T will be the absolute temperature. In case they are not given, 298 will be the constant one. Okay, 298, or you can take it in the form of degree Celsius, means you can take it as a 25 degree Celsius. Clear? So ಯಾವುದು temperature ತಗೋಬಹುದು, ನಮಗಂತೂ already constant temperature ಗೊತ್ತಿದೆ ಅಪ್ಪ. ಆಯ್ತಾ? Similarly for the gas B B also how it will be? PB is equal to CBRT. So LLA ಇದೆಲ್ಲ ಅಂತ ತೆಗಿಬೇಕು. C ಅಕಸ್ಮಾತ್ B ಫೈಂಡ್ ಮಾಡ್ತಿದ್ವಿ B ಬರ್ಕೊಳ್ಳೋದು C ಫೈಂಡ್ ಅಂದ್ರೆ C ಸೆಕೆಂಡ್ ಮತ್ತೆ ಆಮೇಲೆ ಡಿಫರೆಂಟ್ ಕಂಪೋನೆಂಟ್ ಫೈಂಡ್ ಮಾಡ್ತಿದ್ವಿ ಅಂದ್ರೆ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ CCRT. Then afterwards PD is equal to CDRT. Clear? Now from KP for the reaction 1 is KP is equal to PC, PD, PA, PB. These all are stoichiochemical coefficient. Okay, iವೆಲ್ಲ coefficients. These all are coefficients. Done. Now put the values of 2, 3, 4 and 5 in the given equation 6. So 2, 3, 4, 5. 2, 3, 4, 5 ಯಾವುದು? ಅದು 2, 3, 4, 5. ಇವು ನಾಲ್ಕುದ್ರನ್ನ equation 6 ನಲ್ಲಿ ಹಾಕಬೇಕು. So equation 6 ನಲ್ಲಿ ಹಾಕಿದ ತಕ್ಷಣ ಏನಪ್ಪ ಆಗುತ್ತೆ? ಎಲ್ಲ ರಿಪ್ಲೇಸ್ ಆಗುತ್ತೆ, ರೈಟ್? C, C, D, D, R, T, C plus D ಆಗುತ್ತೆ. A, B, sorry, A, B, B, R, T, A plus B. Clear everyone how to substitute it? So just now ಏನು ಫೈಂಡ್ ಮಾಡಿರ್ತೇವೆ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಯಾವ್ಯಾವ ಕಂಪೋನೆಂಟ್ ಮಾಡ್ತಿದ್ದೇವಲ್ಲ ಅದರದ್ದು ಪ್ರೆಷರ್ ಇದು. ಓಕೆ, ಟೋಟಲ್ ಪ್ರೆಷರ್ ಆಫ್ that thing. Okay, total pressure of that thing. So this will be the main equation which you should remember. So ಇದು important to ಇದನ್ನ ನೆನಪಿಟ್ಕೋಬೇಕು. Okay, this is very important. Done. Next here R and T are constant. Now Kp is equal to CCDD or divided by AABB RT, where C plus D minus A plus B is been forming. Where Kc is going to act like what? CCDD, AA and BB. And now above equation 7 will become units. Okay, 7 will become equilibrium constant. Okay, done. Clear? Next comes the units of equilibrium constant. Okay, these are the units of equilibrium constant. Now you have learned about the Kp, Kc and Xc. Means according to the mole fraction, according to the concentration and according to the pressure. Aita? So avutterdu units important. Yakandre ನಾವು ಯಾವಾಗ problem solve ಮಾಡ್ತಿರ್ತೇವಲ್ಲ ಆ time ದಲ್ಲಿ unit upload ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ you people might lose your marks. So ಎಷ್ಟು marks ಅಕಸ್ಮಾತ್ ನೀವು ಏನಾದರೂ upload ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ marks ಖಂಡಿತವಾಗ್ಲೂ ಹೋಗುತ್ತೆ. ಸೊ ಅದರ ಸಲುವಾಗಿ ಯೂನಿಟ್ಸ್ ಹಾಕೋದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. ಕ್ಲಿಯರಾ? ಸೊ ಯೂನಿಟ್ಸ್ ಆಫ್ KP is equal to what? ATM delta Ng. Unit of Kc is equal to mole per liter delta N, where unit of Xc is equal to unitless. Okay, this is means mole fraction is actually unitless. Done. Homogeneous equilibrium is done then. So this all things we learnt it in the homogeneous equilibrium. Clear? Let's move next part to the heterogeneous equilibrium. Understanding everyone? Tilitidena? Yes. Let's move to the heterogeneous equilibrium now. So in a heterogeneous system, all the reactants and the products are in a different phases. So all the reactants and all the products are going to be in a different phases. Clear? For example, in the given reaction, if in case it's in the form of a solid. Okay, ಯಾವುದು CaCO3 solid ನಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಅದು ಯಾವಾಗ ಹೀಟ್ ಮಾಡ್ತೀರಾ, it is also a reversible process itself. Okay, ಯಾವಾಗ ಹೀಟ್ ಮಾಡ್ತೀರಲ್ಲ that time we are going to get what? CaO. What will get it as? CaO. Done. So this CaO ಏನಾಗುತ್ತಲ್ಲ that is actually in the form of what? It's actually in the form of solid. That is actually in the form of solid. Clear? So that solid plus CO2 which is in the gaseous form. Now that reactants and the products are in the heterogeneous phase. So that reactants and the products are in the form of heterogeneous phase. Clear? Similarly, for the reaction NH4HS, which is in the solid state, and NH3 in the gaseous state, plus H2S, which is in the form of gaseous. Means what? We will get the different states. So solid nallide yav different phase bandide? Eradu gas nalli convert agide. Means what? Solid is directly converted into the gas. Sublimation process agtide alli. Aita? So NH2COONH4, which is in the solid state, again it is getting the gaseous state. Means what? Both the reactions which are forming here similarly, these reactions are all acting in the sublimation reaction. Clear? Clear? Itarita ellargu? Heterogeneous equilibrium is done. So ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ reactant and product are in a different phases. So reactant ಒಂದು phase ಬರುತ್ತೆ ಮತ್ತೆ product ಒಂದು phase different ಇರುತ್ತೆ. So reactant in a case reactant ಯಾವುದಾದ್ರೂ solid state ನಿಲ್ಲಿದ್ರೆ product gaseous ನಲ್ಲಿ ಬರುತ್ತೆ ಇಲ್ಲಾದ್ರೂ liquid form ನಲ್ಲಿನೇ ಬರುತ್ತೆ. It will not come again in the solid state. Okay, it will not come again in the solid state. Those all phases are called as heterogeneous equilibrium. Heterogeneous equilibrium, sorry. Next comes factors which are influencing the equilibrium, concentration first, that is reactant concentration decreases, so and product concentration starts decreasing when first the reaction of A plus B which is getting converted to C plus D, that time the reactants concentration will decrease. Clear? So when now product in the reactant and the reversible process ಆಗ್ತಿದೆ ಅಲ್ಲ ಅವಾಗ ಏನಾಗುತ್ತೆ concentration ಅವಾಗನು decrease ಆಗುತ್ತೆ. Clear? ಎರಡು product ಮತ್ತೆ reactant ಎರಡೂತ್ರನು decrease ಆಗುತ್ತೆ whenever you are turning it out from R plus B to C plus D and C plus D to R plus B. Clear? Next, if reactant concentration is increased, if product concentration has been increased, okay, in the case reactant concentration increase madidvi, okay, avage enagutte product concentration increase agutte. If in case reactant concentration increase madidruno product increase agutte. Now equilibrium shifts to reduce to reactant concentration. Here also equilibrium shifts to reduce the product concentration. So the forward reaction is been favored, here the backward reaction is been favored. For that purpose, what you should remember, if in case increasing concentration of one side forward, the other side will be the decreasing. Means what? You people need to remember one thing here. ಯಾವುದಾದ್ರೂ ಒಂದು increase ಮಾಡ್ಕೋತಿದ್ದೀವಿ ಅಂದ್ರೆ product ನಲ್ಲಿನೂ ಅದು increase ಆಗುತ್ತೆ. It's not like in reactant side we are increasing, then the product side will not increase. Okay, ಎರಡೂ ಕಡೆ increase ಆಗುತ್ತೆ. Clear everyone? Understood? Next comes the temperature. So we learned about the concentration. Now let's see how actually it's affecting the concentration according to the reaction. Okay, now we got A plus B and C plus D. Whenever it's getting converted, yavaga A plus B is getting converted, A plus B is getting converted to C plus D. Okay, C plus D. Avage the temperature will increase. Means exothermic process is happening and the temperature will increase. Exothermic andre enu? Heat release ಆಗ್ತಿದೆ ಅಲ್ಲಿ. Heat release ಆಕೊಂತ ಹೋಗ್ತಿದೆ. ಅದಕ್ಕೆ temperature ಅನ್ನು ಜಾಸ್ತಿ ಆಕೊಂತ ಹೋಗ್ತಿದೆ. Right? Clear? Now what happens when you are converting that C plus D into the A plus B? Temperature will increase. There also the temperature will increase, but there will be a endothermic process because ಯಾವಾಗ ನಾವು reaction form ಮಾಡ್ತಿದ್ದೇವಲ್ಲ ಅವಾಗ already heat ಅನ್ನ release ಆಗಿ ಹೋಗಿದೆ. Okay, so ಈಗ product form ಮಾಡ್ಲಿಕ್ಕೆ ಏನಾಗುತ್ತಪ್ಪ, it will take a procedure. Okay, ಅವಾಗ ಏನು ಮಾಡುತ್ತೆ, heat ಎಲ್ಲಾ ಕಡೆಯಿಂದ surrounding ದಿಂದ ಎಲ್ಲಾ ಕಡೆಯಿಂದ heat ತಗೊಂಡು observe ಮಾಡುತ್ತೆ. Clear? To form the reaction. Means reversible reaction. Next ಏನು, in a case reactant ನಲ್ಲಿ temperature increase ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ temperature will start decreasing at the product. Why? Because there is a exothermic and the endothermic process at the reaction. Exothermic ಮತ್ತೆ heat release ಆಗ್ತಿದೆ ಯಾವಾಗ product form ಆಗ್ತಿದೆ ಅಲ್ಲ ಅವಾಗ. So product ಇಂದ reactant ಯಾವಾಗ convert ಮಾಡ್ತಿದ್ದೇವಲ್ಲ ಆ time ದಲ್ಲಿ endothermic process ಆಗ್ತಿದೆ. Means what? ಹೊರಗಿಂದೆಲ್ಲ heat observe ಮಾಡಿ product reactant ಅಲ್ಲಿ convert ಮಾಡ್ತಿದೆ. So ಅದರ ಸಲುವಾಗಿ ನೀವು ಯಾವಾಗ reactant side ನಲ್ಲಿ temperature increase ಮಾಡ್ತಾರಲ್ಲ product side ನಲ್ಲಿ temperature decrease ಆಕೊಂತ ಹೋಗುತ್ತೆ. Clear? So equilibrium will shift to reduce the temperature. It will shift to reduce the temperature. Clear? So equilibrium ಏನು ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡುತ್ತೆ, ಅದರ ಸಲುವಾಗಿ ಅದು completely reduce ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡುತ್ತೆ temperature ನ, because already temperature has been increasing. So if you want it to be equilibrium, ಅವಾಗ ಇದು equilibrium slowly it will start making it decrease. Clear? So here what happens, equilibrium will shift to increase the temperature. So here the temperature will be increasing. So equilibrium here it will help to come in the equal way. So idರಲ್ಲಿ already ಕಡಿಮೆ ಆಗಿದೆ ಅಲ್ಲ, in RHS it has been already less. So ಅವಾಗ ಏನು ಮಾಡುತ್ತೆ, ಆ RHS side ನಲ್ಲಿ ಅದು increase ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ. So it will start increasing. So the endothermic reaction will be favored at the reactant side and exothermic reaction will be favored at a product side. Why? Because in this way we'll have an idea that where the reaction should be at the equal amount. Okay, now in case equilibrium ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ, endothermic reaction ಮಾಡಿದ್ವಪ್ಪ. Okay, ಹೊರಗಿಂದ reheat ತಗೊಳ್ಳಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿತ್ತು ಪ್ರಾಡಕ್ಟ್ ರಿಯಾಕ್ಟೆಂಟ್. ಓಕೆ, ರಿಯಾಕ್ಟೆಂಟ್ ಅಕಸ್ಮಾತ್ ಹೊರಗಿಂದ endothermic reaction ಇಂದ ಮೀನ್ಸ್ ಇಟ್ ಇಸ್ ಗೆಟಿಂಗ್ ಸ್ಟಾರ್ಟೆಡ್ ಅಬ್ಸರ್ವಿಂಗ್ ದ ಹೀಟ್. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಎಕ್ಸೋಥರ್ಮಿಕ್ ಅಂದ್ರೆ ರಿಲೀಸ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ರಿಯಾಕ್ಷನ್. ಆ ಟೈಮ್ದಲ್ಲಿ at one certain point it will come at a equilibrium. Clear? That is what they are trying to do the experiment with the help of the temperature. So if the forward reaction is exothermic, then the backward reaction will be endothermic and the vice versa. That's what forward reaction akasmat exothermic idre, backward reaction endothermic irutte. In a case and vice versa. In case it is different, it will be opposite of that. Done? Next comes the pressure. Pressure nalli enaguttappa. So decrease pressure means what now? Fewer gas of the molecules on the right hand side, and here what happens, the pressure will start decreasing. The pressure will start decreasing whenever fewer gas molecules on the right hand side. So illi kadame gases irutte, less gas. Okay, less gas. So now in a case if we are converting from the product to the reactant side, that time the pressure will start increasing. Pressure yavaglu increase agli start agutte. Main thing enide ali, more number of gas molecules on the left hand side. So left hand side nalli molecules ಜಾಸ್ತಿ ಇರುತ್ತೆ, molecules will be more that time. Clear? So next comes what? Pressure is increasing. Here the pressure is been decreasing. So ಇಲ್ಲಿ A plus B ಯಾವಾಗ ರಿಯಾಕ್ಟೆಂಟ್ ಇಂದ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗ್ತಿದೆ ಅಲ್ಲ, ಅವಾಗ ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಆಕೊಂತ ಹೋಗುತ್ತೆ. Pressure will start increasing. But what happens at the RHS? What happens at the RHS? Pressure is decreasing. Pressure is decreasing. Clear? So ಯಾವಾಗ pressure decrease ಆಕೊಂತ ಯಾವಾಗ ಹೋಗುತ್ತೆ, ಯಾವಾಗ ಪ್ರಾಡಕ್ಟ್ ಇಂದ reactant side ನಲ್ಲಿ ಕನ್ವರ್ಟ್ ಮಾಡುತ್ತ ಮುಂದು. Clear? Understanding everyone? Okay. Now equilibrium will shift to reduce the pressure. Equilibrium will shift to reduce the pressure. Means what? Equilibrium ಏನು ಮಾಡುತ್ತೆ, pressure ಅನ್ನ reduce ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ at the reactant side. Okay, reactant side ನಲ್ಲಿ equilibrium pressure ನ ಕಡಿಮೆ ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ. So ಅದರ ಸಲುವಾಗಿ at the RHS ಏನಾಗುತ್ತೆ, product side ನಲ್ಲಿ equilibrium will shift to increase the pressure. Why? Because it's already decreasing. I want it to get increased at the product side. So equilibrium ಏನು try ಮಾಡುತ್ತೆ, I will increase the pressure there. Okay, I will try to increase the pressure so that the reaction will become backward or a forward, like that. Okay, next becomes what? In the reactant side of the reaction with the fewer gases or our moles will be favored. So this here what happens, side of the reaction is more gases, moles will be favored. Okay, moles will be favored. Here the fewer moles will be favored. Okay, ಎಲ್ಲ LHS ನಲ್ಲಿ ಕಡಿಮೆ moles ಅನ್ನ ಫೇವರ್ ಮಾಡುತ್ತೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ, increase of the pressure or decrease of the pressure ಆಗಿ. ಆದ್ರೆ RHS ನಲ್ಲಿ ಜಾಸ್ತಿ ಫೇವರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಓಕೆ, RHS ನಲ್ಲಿ ಜಾಸ್ತಿ ಫೇವರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಅದರಿಂದ ಏನು ನೆನಪಿಟ್ಕೋಬಹುದು ನಾವು, if the number of the gas molecules is the same on either side, okay, molecules same idre LHS ಮತ್ತೆ RHS ನಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ, the changing of the pressure will have no effect. ನೀ ಏನು ಚೇಂಜ್ ಮಾಡಲಿ, ಎಫೆಕ್ಟ್ ಏನು ಪ್ರೆಷರ್ ಚೇಂಜ್ ಮಾಡಲಿ, that will not matter to them. okay, ನೀ ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡು ಡಿಕ್ರೀಸ್ ಮಾಡು ಏನು ಮ್ಯಾಟರ್ ಆಗಲ್ಲ. ಇನ್ ಕೇಸ್ LHS ಮತ್ತೆ RHS ನಲ್ಲಿ moles ಸೇಮ್ ಇದ್ರೆ, moles are same, then it is no use of changing it. Clear? Done. Next comes the application of equilibrium constant. Applications of equilibrium constants. Clear? Okay, let's start with the applications then. Yes, before considering the applications of the equilibrium constant, let us summarize the important features of the equilibrium constant as follows. So, expression for equilibrium constant is applicable only when the concentration of the reactant and the product have attained the constant value at equilibrium state, And the value of the equilibrium constant is dependent of initial concentration of the reactants and products. So, value of the equilibrium constant to independent ide yav tara, means why it is independent? It's actually independent of initial concentration. Initially now yav concentration tagotiddala and independent agirutte. It will be always be independent. Understanding? Yes. Next, equilibrium constant in the temperature is dependent having a one unique value for a particular reaction. One unique value for a particular reaction which will be represented by the balanced equation at a given temperature. A balanced equation at a given temperature. Clear? Next comes what? The equilibrium constant for the reverse reaction is equal to the inverse of the equilibrium constant for the forward reaction. Clear? So these things you should remember it before we learn about the applications of the equilibrium constant. Okay, we have lots of applications. So next, the equilibrium constant K for the reaction is related to the equilibrium constant of the corresponding reaction. So whose equation is being obtained by a multiplying or dividing the equation for the original reaction by a small integer. So let us consider the application of equilibrium constant to how it is applications are. Concentrate applications are important. Predict the extent of the reaction on the basis of its magnitude. On the basis of its magnitude, you can predict the extent of the reaction. Yalli tanka hogbohudu. Okay, ಆ ರಿಯಾಕ್ಷನ್ ಎಲ್ಲಿ ತನಕ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಮಾಡಬಹುದು, ನಮಗೆ ಯಾವುದೋ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗ್ತಿದೆ, ಅದರಿಂದ ಎಲ್ಲಿ ಪ್ರಾಡಕ್ಟ್ ಕರೆಕ್ಟ್ ಆಗಿ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ನೋ ಸೈಡ್ ಪ್ರಾಡಕ್ಟ್ಸ್, ಓನ್ಲಿ ಪ್ರಾಡಕ್ಟ್ ನೀಡ್ಸ್ ಟು ಫಾರ್ಮ್. ಆ ಎಕ್ಸ್ಟೆಂಟ್ ತನಕ ಏನ್ ಮಾಡುತ್ತೆ, how it will be predict on the basis of magnitude. On the basis of magnitude it will be decided. Clear? So ಈಗ ಯಾವ್ದಾದ್ರು ಒಂದು ರಿಯಾಕ್ಷನ್ ಆಗ್ತಿದೆ, ಆ ರಿಯಾಕ್ಷನ್ ಎಲ್ಲಿ ಹೋಗಿ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ, ಯಾವ ತರ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಹೇಗೆ ಗೊತ್ತಾಗುತ್ತೆ ನಮಗೆ, ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ magnitude of the reaction. We are going to get that thing. Okay. Next, predict the direction of the reaction and the calculate equilibrium concentration. And we need to calculate the equilibrium concentration. So once you predict the direction, that is magnitude of the reaction, and then you are going to calculate the equilibrium concentration. So adrinda niಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಎಲ್ಲಾಗುತ್ತೆ ಅನ್ನೋದು, we will get the reaction. ಈ reaction ಗೊತ್ತಾದ ತಕ್ಷಣ you can easily find its equilibrium constant. Means what? We can calculate the equilibrium constant easily according to the reactant and the product. Done. So ಒಂದು ವಿಷಯ ಏನಿರಬೇಕು ಇಲ್ಲಿ, ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಇರಬೇಕು. ಸೊ ಅದಕ್ಕೆ ಹೇಳಿರೋದು ಸ್ಟಾರ್ಟಿಂಗ್ ಆಫ್ ದ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ಏನ್ ಹೇಳಿದಪ್ಪ ನಾನು, ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಅನ್ನ ಏನು, ಕೆಮಿಕಲ್ ಇಕ್ವೇಶನ್ ಅನ್ನ ಏನು ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಬಿಕಾಸ್ ಅದರ ಮೇಲೆನೆ ನಮಗೆ ಗೊತ್ತಾಗೋದು ಕೆಮಿಕಲ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ಯಾವ ತರ ರಿಯಾಕ್ಷನ್ ಆಗ್ತಿದೆ, ವೆದರ್ ಇಟ್ ಇಸ್ ಅ ರಿವರ್ಸಿಬಲ್ ಪ್ರೊಸೆಸ್ ಆರ್ ವಾಟ್, ವೆದರ್ ಇಟ್ ಇಸ್ ಅ ಇರ್ರಿವರ್ಸಿಬಲ್ ಪ್ರೊಸೆಸ್ ಆರ್ ವಾಟ್, ವೆದರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫೈಂಡ್ ದ ಪ್ರಾಡಕ್ಟ್, ಏನ್ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಮಾಡ್ತಿದ್ದೇವಲ್ಲ ಅದು ಯಾವ ತರ ಫೈಂಡ್ ಮಾಡ್ತಿದೆ, ವೆದರ್ ದ increase of the pressure is happening or what, whether it is a decrease in the pressure is happening, temperature apply ಮಾಡ್ತಿದ್ದೇವೋ, ಯಾವುದು catalyst apply ಮಾಡ್ತಿದ್ದೇವೋ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಮಾಡ್ಲಿಕ್ಕೆ, ಅವೆಲ್ಲ ಹೇಗೆ ಗೊತ್ತಾಗುತ್ತೆ, when you know about the chemical reactions. ಆಯ್ತಾ? ಸೊ ರಿಯಾಕ್ಷನ್ಸ್ ಹೇಗೆ ಗೊತ್ತಾಗುತ್ತಲ್ಲ ಅದ್ರ ಪ್ರಕಾರ ನಿಮಗೂ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ ಅದ್ರದ್ದು. ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ ಅಬೌಟ್ ದ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ಇಟ್ಸೆಲ್ಫ್, ದಿಸ್ ಚಾಪ್ಟರ್. ಓಕೆ. Next, how to calculate the Kp and Kc. Okay, how you are going to calculate the Kp and Kc, that we are going to learn it in a very detailed way. Like calculation of Kc, then calculation of Kp, then dissolution of the PCl5. This all things we are going to learn now. Yes. So calculation of a Kp and Kc, where homogeneous equilibrium in gaseous phase, homogeneous equilibrium in solution phase, and equilibrium constant for the various heterogeneous equilibrium. How you are going to calculate? On the basis of these three things you are going to learn, or you are going to calculate the things. First is about the homogeneous equilibrium in a gaseous phase. So homogeneous equilibrium definition ಏನಂತ ನಿಮಗೆ already ಗೊತ್ತಾಯಿತು, just now ಕಲಿಸಿದ್ದೆ, right? Just now you have learnt it, right? right? Now formation of a nitric oxide ಹೇಗಪ್ಪ formation ಆಗ್ತದೆ nitric oxide ಅದನ್ನ understand ಮಾಡ್ಕೊಳ್ಳೋಣ. That is delta n is equal to 0. So calculations how possible is if in case suppose the initial concentration of N2 and O2 is A and B. Okay, initial concentration of N2 ಮತ್ತೆ O2 ಏನಿದೆ A ಮತ್ತೆ B ಇದೆ. Clear? So respectively. So N2 is what? N2 is A and O2 is B. Okay, now respectively X is the degree of dissociation. Let us consider X as what? Degree of dissociation. Okay, degree of dissociation. Now initial moles is actually equal to, let us consider, okay, we'll consider according to the things itself. N2 andre ಈಗ just ಹೇಳಿದ್ರೆ A ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೇಕು, O2 ಅಂದ್ರೆ B ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ವಿ, right? 2 N2 ಫಾರ್ಮ್ ಆಗುತ್ತೆ, product will be what? 0. Now moles of the equilibrium will be how much? ಎಷ್ಟು moles find ಮಾಡ್ಬೇಕು ನಾವು? A minus X, B minus X. Simple guys. Yes. Now active mass per mole is going to be A minus X divided by V, B minus X divided by V is equal to 2x divided by V. Here V is the volume of the container in the liter. Here what will act? Volume of the V will act like a volume of the container in a liter. Done. Now here V is the volume of the container in the liter. According to the law of mass action, Kc is equal to, means we are finding the mole fraction right now, that is NO2 divided by N2 plus O2. NO2 divided by N2 plus O2 means what? Here whatever the product we have taken, no, here product divided by A plus B. Okay. Substitute the values in the above equation in the form of, so this values which we have taken it, that only we are going to substitute it here. Okay, 2x divided by V square. Done. So A minus X divided by B and B minus X divided by Y. Okay, V. Now 2 into 2 to the 4, 2 to the 4 x square. A minus X mother B minus X divided by V, we can take the LCM, we can remove it out. Okay, then what will be the answer? A minus X divided by into B minus X. Now Kc for this reaction is independent of V, means it is what? Is independent. It is not necessary that it should depend on how many liters you have taken, how much volume you have taken. It does not depend. So what? In a simple way, Kc will not depend on V. Okay, Kc will not depend on V. Note, you can take it. Okay, Kc will not depend on volume. Clear? It will not depend on the volume. This much you remember, enough. Done. Next comes the calculation of Kp. Now here what happens? All the things being same as above except the pressure. Okay, here all the things will be same. Just the thing is pressure will be changed in the Kp. So because we are learning about the calculating the pressure, then obviously the pressure will be different, right? So let P be the atmosphere is the pressure at equilibrium, where initial moles is going to be A, B, that will be forming 0. Same reaction how we have taken it. In that only we need to take it. Okay, yella same is okay. Now what happens with the total number of the moles? That is will be A minus X plus B minus X plus 2X. That will be forming A plus B. Done. A plus B. Now let us calculate that. Okay, namagiga P N2 find madodide. We are going to first find with the P N2. Let us consider P N2 is equal to A minus XP and A plus B. Okay, so P N2, where it went? Yes, ಇಲ್ಲಿ P N2 find madodide andre, you what they have done is they have taken A minus X, they have taken A minus X and A plus B at the RHS, then they are doing it with the help of P. Same we are going to consider in the form of a O2 also, that will be B minus X of P divided by A plus P. Now what happens is both the things means what? We know already A minus X and B minus X, together it will be 2X. Right? Together it will be 2X. That's what I have substituted, 2X of P divided by A plus B. Done. According to the law of mass action, the Kp is equal to P/O divided by square divided by, means what in a simple way? n total divided by NA plus NB. Ee tara neevu nenanpitkobodu. Okay. Now let us substitute the P and O, P and 2 and all those things. Means this values only, let us substitute it here. So once you substitute this values, this all three values, when you are going to substitute it, we are going to get this answer. What we are going to get? This answer. Clear? Theta. That is Kp is equal to 2x P A plus B, A minus P P A plus B, B minus x P A plus B. This is whole square. Let us consider 4x pi P, that is 4x square divided by Ax, that is all, it will get cancelled everything. A plus B ella cancel agutte. Only the few things will remain up here. Only the few things will remain up here. P cancel aitu completely. So again cancel agutte, A plus B cancel agutte, A plus B cancel agutte, A minus x ಮತ್ತೆ B minus x ಉಳಿಯುತ್ತೆ, A minus x ಮತ್ತೆ B minus x ಉಳಿದಿದೆ. So thermal dissociation of the for the phosphorus pentachloride is going to be what? Delta N will be always be greater than 0. This is important. Clear everyone how the calculation is happening? ಯಾವ ತರ calculation ಆಗ್ತಿದೆ ಗೊತ್ತಾಯ್ತಾ? Understood? Next, dissociation of a PCl5. So now calculation of a Kc, suppose one molecule of a PCl5 is taken in a closed container of, it has been taken into the closed container of V liter. So closed container tagondidare V liter and with the volume of the liter, how much they have taken, that depends on. Okay. Further, at its equilibrium, X moles of PCl5 is been dissociated. So adat salagi initial moles en tagolodu or helidare already 1 mole anta, 1 mole initial product to 0 0. So let us consider as 1 minus X, and here product reactant side we can consider as X and X. Clear? Now what happens with the concentration at the per mole wala? Okay. So 1 minus X according to the liter, because it is dependent on the volume. Because it's dependent on volume. Clear? It's dependent on the volume at its liters. Okay. Now, according to the law of mass action, we know that Kc is equal to PCl3 Cl2 divided by PCl5. Means what? PCl3 which is getting reacted with Cl2. Which is getting reacted with Cl2. Idu. This divided by this. Done. That I have done it. Kc. Done. Now substitute the values in the value of the equation. So idukela ಏನು ಕೊಟ್ಟಿದಾರ PCl3 ಅಂದ್ರೆ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ ನಾವು x divided by v ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋದು. Done. So ಇಲ್ಲಿ PCl5 ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿವೆ 1 minus v ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿವೆ. Let's just write it in that 1 minus x divided by v. Now that Kc is equal to x square. X square means you should just remove the LCM here. X square divided by 1 minus x into v. Clear guys? Done. Understood this? Understanding? Understand that? Now next part, it's going to come about the formula. Okay. Now ಹೇಗೆ formula ಅನ್ನು ಬರ್ಕೋಬಹುದು ಈಗ. The formula of the Kc has almost V in the denominator. Hence the equilibrium will be affected by the V of the reaction container for the given reaction. As we know that what type of a liter, ಎಷ್ಟು ನೀರನ್ನು ತಗೊಂಡಿವೆ, ಎಷ್ಟು ಲಿಕ್ವಿಡ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೇವೆ, ದಟ್ ವಾಲ್ಯೂಮ್ ಎಷ್ಟು ತಗೊಂಡಿದ್ದೇವೆ, ಅದರ ಮೇಲೆ ಡಿಪೆಂಡೆಂಟ್ ಆದ್ರೆ ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆಗ್ಬೋದು. ಸೊ ನಾವು ಹೌ ಟು ಮೇಕ್ ಇಟ್ ಇಂಡಿಪೆಂಡೆಂಟ್. ಓಕೆ, ಹೇಗೆ ಮಾಡ್ಕೋಬಹುದು, ಇಲ್ಲಾಂದ್ರೆ ಮಾಡ್ಕೊಳ್ಳಿಲ್ಲ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಯಾವ ತರ ಇನ್ಕ್ರೀಸ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತಿದೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅನ್ನೋದು ನೋಡೋಣ. ಸೊ ವೇರ್ V of the reaction is a container for the given reaction, where if x is actually very less than the 1, then 1 minus is actually equal to 1. So let us consider Kc is equal to x square divided by V. Okay, x square divided by V. Now here what happens, we need to get the value of x. Yes, mole fraction is the main important. How many moles are present in that liter? Yav tagondidalla product to yav component tagondidalla adu eshtiದೆ appa ಅನ್ನೋದು ನಮಗೆ ಗೊತ್ತಿರಬೇಕಲ್ಲ. So x square is equal to Kc into V, where x square is directly proportional to V. Yes, it's directly proportional to V. Right? So x is actually directly proportional to root V. Means what? The square will go here. Square will go here and it will become root. Okay. Next, if we increase the volume, the dissociation of the X is also increased. So, volume increase martira, dissociation also will be increased. Dissociation of that volume also will be increased. Clear till here? Clear? Yes. Let's move to the next. That is about the calculation of P. Okay, calculation of Kp now. Let us consider same equation, that is PCl5, which is giving PCl3 plus Cl2. But initial concentration or initial moles enagutte 100, 100. Now, moles of that equilibrium will be 1 minus x of x on x. Here means what? Product will be 1 minus x. Okay. Reactant ಎರಡಿದೆ ಅವಕ್ಕೆ ಏನಾಗುತ್ತೆ x ಮತ್ತೆ x. Then now total number of the moles at the equilibrium will be how much? 1 minus x plus x plus x. Then moles. Now according to the law of mass action, which we have learnt it, what will happen? Kp is equal to PCl5 into PCl2. Means this both the things. Means product in find agide alla. Sorry. Reactant ಏನಇದೆಯಲ್ಲ, reactant divided by product. Clear? Kp is equal to, according to the law of mass action, we know that it is a number of moles divided by molar mass, right? Molar mass divided by number of moles ಅಂತ ಹಾಕಿದ್ವಿ. ಈಗ PCl3 find ಮಾಡೋದಿದೆ at equilibrium of PCl3. Means what? We need to know that the reactant side ಏನಿದೆ, what is at the reactant side. So ಅದ್ರ ಸಲುವಾಗಿ PCl3 find ಮಾಡೋದು ಆಯ್ತಾ. So PCl3 in find ಮಾಡ್ಲಿಕ್ಕೆ ಆಗತ್ತಂದ್ರೆ we know that PCl3 is a x, that is x. PCl2 is also x, but we will consider as a p here. Okay, and divided by 1 minus x, and divided by 1 minus x. Clear? So now PCl2 is actually equal to kx into p. This p will actually go here. That's what here is. Okay, PCl2 is equal to x plus into p divided by 1 plus x. Clear? 1 plus x. Now, ಈಗ P means ಏನೋ PCl2 ತಗೊಂಡಿದ್ದೇವೆ ಇಲ್ಲಿ, ಅದನ್ನ ನಾವು ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು PCl5 ಗೆ. Okay, now what will happen? 1 minus x, that P will again come here, divided by 1 plus x and 1 plus x. Now substituting the values in the above equation of Kp, let us substitute it in the above equation in the Kp. Kp is equal to what? X into P divided by 1 plus x and x into P divided by 1 plus x. So divided by 1 minus x into P and 1 plus x. So substitute, but ಏನು ಕೊಟ್ಟಿದಾರಲ್ಲ, ಇದೇನು ಕೊಟ್ಟಿದಾರಲ್ಲ ಅದನ್ನ just substitute ಮಾಡಿದ್ದೇನೆ. Nothing much I have done it, don't get confused. Okay, ಏನು ಕನ್ಫ್ಯೂಷನ್ ನೆಸೆಸಿಟಿ ಇಲ್ಲ. ಜಸ್ಟ್ ನಾನು ಏನು ಫೈಂಡ್ ಮಾಡಿದ್ದೆ ಅಲ್ಲ ವ್ಯಾಲ್ಯೂ ಅನ್ನ, ಆ ವ್ಯಾಲ್ಯೂ ಅನ್ನೇ ಜಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೇನೆ ಅಷ್ಟೇ. ಓಕೆ, ಏನು ವ್ಯಾಲ್ಯೂ ಅನ್ನ ಡೈರೆಕ್ಟ್ಲಿ ಜಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೇನೆ. So here the equation of the Kp is not independent of the pressure. So the Kp is actually not independent of the pressure. Now how we learnt that about the volume, how it is not dependent on the concentration, ಆ ತರ ಇಲ್ಲ. ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ, actually it's actually not independent of the pressure. It needs the pressure. Kp needs the pressure. Suppose if in case x is actually lesser than the 1, then 1 minus is actually equal to 1 minus x square is equal to the 1. So Kp is equal to x square p. Kp is equal to x square p. So x square, there is this x square which we are finding it is equal to Kp divided by p. Kp divided by p. For that purpose, x is inversely proportional to 1 by root p. Inversely proportional to 1 by root p, where the degree of dissociation of the PCl5 is inversely proportional to degree of dissociation means x, which is actually degree of dissociation. Okay, okay, is equal to degree of dissociation is actually inversely proportional to what did they have told? Square root of the pressure. Done? Yes, this is all about this. Next is homogeneous equilibrium in a solution phase. Homogeneous mixture in a solution phase. So just 5 minutes, I will be back. Okay, I'll be back in a 5 minutes. Then we'll continue, okay? Now audible enough? Let's start with the homogeneous equilibrium is solution phase. In solution phase. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಸೊ ಹೆಟ್ರೋಜಿನಿಯಸ್ ಮುಗಿತು ಈಗ ಹೋಮೋಜಿನಿಯಸ್ ನಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅನ್ನೋದು ನೋಡೋಣ ಓಕೆ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಈಥೈಲ್ ಎಸಿಟೇಟ್ ಅಲ್ಲಿ PCl5 ನೋಡಿದ್ವಿ ಇಲ್ಲಿ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಈಥೈಲ್ ಎಸಿಟೇಟ್ ಹೇಗಾಗ್ತಿದೆ ಅನ್ನೋದು ನೋಡೋಣ ಆಯ್ತಾ formation of ethyl acetate where the equilibrium is represented as how they are equilibrium represented C2H5OH which is in the form of a liquid getting reacted with CH3COOH which in the liquid film initial moles in consider ಮಾಡ್ಕೊಳ್ಳೋಣ C2H5OH ದು 1 ಅಂತ ಆಮೇಲೆ CH3COOH ದ 1 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳೋಣ ಆಯ್ತಾ so we'll get the product as what CH3COOH C2H5 plus H2O 0 0 let us consider XX and your 1 minus X and 1 minus X means ಹೇಗೆ heterogeneous ನಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ವಲ್ಲ ಸೇಮ್ ಅದೇ ತರ homogeneous ನಲ್ಲಿನೂ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬಹುದು ಆಯ್ತಾ so KC is equal to CH3COO C2H5 and H2O and C2H5OH divided by CH3COOH you will know what is that CH3COO C2H5 ಏನದು that is going to be 0 and H2 is going to be 0 again that is X plus X plus X or into it is sorry okay ಹೀಗೆ ಮಾಡ್ಕೋಬಹುದು X into X divided by X oh sorry X into X divided by what is the C2H5OH 1 minus X 1 minus X CH3COH is also 1 minus X clear we can take it in this way then next same ಅದೇ ತರ ತಗೊಂಡಿದ್ದೇವೆ ಇಲ್ಲಿ ಅದನ್ನೇ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋದು ಡೈರೆಕ್ಟ್ ಆಗಿ in the form of a V means what in the form of a volume you are going to consider that in the form of a volume if you add it you are going to get this as a reaction clear you are going to get this as a reaction simple right so next equilibrium constant for the various heterogeneous equilibrium results from the reversible reaction yes means what reversible ಅಂದ್ರೆ heterogeneous ನಲ್ಲಿ ಯಾವಾಗಲೂ ಏನೇನ್ ನಾವು ರಿಯಾಕ್ಟೆಂಟ್ ತಗೊಂಡಿರ್ತೇವಲ್ಲ ಏನ್ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗಿರುತ್ತಲ್ಲ ಪ್ರಾಡಕ್ಟ್ ಮತ್ತೆ ರಿಯಾಕ್ಟೆಂಟ್ ಆಗಿ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಕ್ಲಿಯರಾ ಸೊ ಇಲ್ಲಿ ಆಮೇಲೆ the law of the mass action is applicable to a homogeneous equilibrium and is also applicable to the heterogeneous system also clear now decomposition of a solid that is CaCO3 into solid CaO and gaseous CO2
CO2. Now, decomposition of the solid, how it's going to happen with the CaCO3 into solid of CaO and gaseous of CO2 is, let us consider A has a moles. Okay, let us consider A has its moles of a CaCO3. A has what? CaCO3. Clear? Are taken in a vessel of a volume V liter at a temperature of T. T is going to be the temperature. V is going to be the volume. Done? So next comes what? Moles of the initially the moles of the, it's going to be A00, moles of the equilibrium is going to be A minus X, and XX means we need to consider the moles, right guys? So that is going to be what? K equation, that is going to be equilibrium, sorry. K equilibrium is going to be CaO, CO2 divided by CaCO3 means what? Reactant into reactant divided by product. Clear? Has CaCO3 and CaO, which is in solid state, are pure solids, so their concentration is actually going to be unity. The concentration will be at a unity. So therefore Kc is equal to PCO2 divided by RT. PCO2 divided by RT, where KCRT, here we have taken the RT, KCRT is equal to the PCO2, is actually equal to the PCO2. Then, understood how? Means we need to find the PCO2, so we have done it. Or else if people want, then you can keep it in this way also. No problem, guys. Okay? No problem. Okay? However you want, you can keep it, not and any issue is there. Okay? Next comes, since KCR and T are constant, their product will also be a constant, which is referred as Kb, which is going to be referred as what? Kp. Clear? So therefore Kp is equal to CO2, that will be XRT divided by V. So therefore Kp is equal to PCO2, that will be equal to XRT divided by V. XRT divided by V. Done? Understood? Next, now comes the main, that is also important, Le-Chatela's principle and what actually it states. Okay, Le-Chatela's principle and what it actually states. So if stress is applied on the system in equilibrium, if it is the case you are applying a stress is applied in the system in an equilibrium manner. Stress andre eno ಈಗ ನಾರ್ಮಲ್ ಆಗಿ ನಿಮ್ಮ ಲೈಫ್ ನಲ್ಲಿ ತಿಳ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ಸೊ ನಿಮ್ಮ ಲೈಫ್ ನಲ್ಲಿ ಯಾರೋ ಒಬ್ರು ಸ್ಟ್ರೆಸ್ ಹಾಕ್ತಿದಾರಪ್ಪ ಫುಲ್ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಒಂದು ವರ್ಷ ಆಯ್ತು, ಟೆಂತ್ ನಲ್ಲಿ ಪರ್ಸೆಂಟೇಜ್ ಮಾಡಿ ಅಂದ್ರು, ಅದಾದ ತಕ್ಷಣ ದೇ ಟೋಲ್ಡ್ ಯು ಟು ಡೂ ಇಟ್ ಇನ್ ದ ಸೆಕೆಂಡ್ PUC ಆಲ್ಸೋ. ಸೆಕೆಂಡ್ PUC ಹೋದ್ರೆ ಮುಗಿದೋಯ್ತು, ಮತ್ತೇನಿಲ್ಲ, ಜಸ್ಟ್ ಡಿಗ್ರಿಗೆ ಹೋಗ್ಬಿಟ್ರೆ ಸಾಕು, ಚಲೋ ಕಾಲೇಜ್ ಸಿಕ್ಬಿಟ್ರೆ ಸಾಕು. ಕಾಲೇಜ್ ನಲ್ಲಿನೂ ಪಾಸ್ ಆಗ್ಬೇಕಲ್ಲ, ಇಟ್ಸ್ ನಾಟ್ ಲೈಕ್ ಯು ವಿಲ್ ಫೇಲ್ ಇನ್ ದ ಕಾಲೇಜ್, ರೈಟ್? So that is what the things are happening here. Okay, if stress is applied on the system in equilibrium, the equilibrium condition is upset. The equilibrium condition is going to be upset. So the net reaction occurs in that direction, which tends to relieve the external stress, which will tend to release the external stress, and finally a new equilibrium is being attended. So finally what happens? A new equilibrium is going to be attended. Clear? So to understand its application to the system, let us consider the following reactions or examples. Okay, so N2, which is getting reacted with 3H2. Okay, N2 yavaga 3H2 jode react agutte, which is in the form of a gaseous itself. Okay, what we are going to get? 2NH3, which is in the gaseous state. Okay, 2NH3, which is in the gaseous state. Clear? So now if in case delta H means change in the heat, whatever it is happening, there it is going to be minus 92 kilojoules for forward reaction. Okay, forward reaction. ಯಾವಾಗ forward reaction ಆಗ್ತಿರುತ್ತಲ್ಲ, ಅವಾಗ ಎಷ್ಟು ಚೇಂಜ್ ಆಗುತ್ತೆ delta H, that is going to be minus 92 kilojoules. ಈಗ backward reaction ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಎಷ್ಟಾಗುತ್ತೆ? plus 92 kilojoules. So what, always remember in Le-Chatela's principle, ಯಾವಾಗ forward reaction ಇದೆ ಅವಾಗೆಲ್ಲ it will be in the form of a negative. ಏನಿರುತ್ತೆ backward ಯಾವಾಗಲೂ the kilojoules, and it will be considered in the form of kilojoules also. If in case it is in the negative, sorry, if it's the case in the backward reaction, then always it will be positive. Always it will be positive. This you should remember, don't forget it. Le-Chatela's ಮೇಲೆ 100% sure ಆಗಿ NEET ಮೇಲೆ ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ, ಆಯ್ತಾ? ಸೊ ಬಹಳ ಸಲ ರಿಪೀಟ್ ಆಗಿದೆ ಕ್ವಶನ್ ಈ ಟಾಪಿಕ್ ಇಂದ ಸಬ್ ಟಾಪಿಕ್ ಇಂದ. ಓಕೆ, ದೆನ್ next, effect of temperature. Effect of temperature means what? How the temperature can be increased by adding the substances there, that we are going to learn. Then we have a effect of a pressure, then effect of a catalyst, then we have some evolutions also according to the melting point and freezing point. Okay, not freezing point, yes, melting point and boiling point. Okay, effect of a temperature. Temperature can be increased by adding heat. Okay, temperature can be actually increased by adding up the heat. Okay, adding up the heat, and can be decreased by taking out the heat from the system. So taking out the heat from the system. So temperature ಯಾವಾಗ increase ಆಗುತ್ತೆ, ಯಾವಾಗ ನಾವು ಆ heat ಅನ್ನ add ಮಾಡ್ತೇವೆ. Means what? When you are applying the heat to that, temperature will increase. So it can be decreased when we can take it out of the heat. Take it out means what? ಎಂಡೋಥರ್ಮಿಕ್ ಪ್ರೊಸೆಸ್ ನಲ್ಲಿ ಯಾವಾಗಲೂ ಟೆಂಪರೇಚರ್ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ. ಎಕ್ಸೋಥರ್ಮಿಕ್ ಪ್ರೊಸೆಸ್ ನಲ್ಲಿ, ಸಾರಿ ಎಕ್ಸೋಥರ್ಮಿಕ್ ಉಲ್ಟಾ ಹೇಳ್ಬಿಟ್ಟಲ್ಲ, ಎಕ್ಸೋಥರ್ಮಿಕ್ ಪ್ರೊಸೆಸ್ ನಲ್ಲಿ ಹೀಟ್ ರಿಲೀಸ್ ಆಗಿರುತ್ತೆ, ಅದಕ್ಕೆ ಟೆಂಪರೇಚರ್ ಯಾವಾಗಲೂ ಕಡಿಮೆ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ. ಎಂಡೋಥರ್ಮಿಕ್ ನಲ್ಲಿ ಜಾಸ್ತಿ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ, ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಅಬ್ಸರ್ವಿಂಗ್ ದ ಹೀಟ್ ಫ್ರಮ್ ದ ಸರೌಂಡಿಂಗ್. ಕ್ಲಿಯರ್ ಎವ್ರಿವನ್? Yes. Now increase the temperature by supplying the heat. Okay, when you are increasing the temperature by supplying the heat, what happens? According to the Le-Chatelier's principle, the distributed equilibrium state will move in that direction where heat is being observed. Direction where actually the heat is going to get observed. Clear? That's what I wrote. Endothermic process is happening. Okay. So endothermic direction in case of the given situation. Okay, in the case of the given situation, reverse direction will be favored, that being endothermic, till whole point of extra heat is being consumed. So NH3 will be decomposed on increasing temperature. Okay, ಯಾವಾಗಲೂ ಅದ್ರ ಸಲುವಾಗಿ ಏನಾಗುತ್ತೆ, ಆಲ್ಮೋಸ್ಟ್ NH3 ಏನಿದೆ ಅಲ್ಲ, so NH3, when what is there, no, that NH3 what is there, that will always decompose. Okay, that will always decompose on increasing the temperature, Clear? Next, decreasing the temperature by extracting the heat means what? Decreasing the temperature means what? Extracting the heat means what? ಟೆಂಪರೇಚರ್ ಡಿಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ, ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿ ಟೆಂಪರೇಚರ್ ಡಿಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ. ನಮಗೀಗ ಜಾಸ್ತಿ ಟೆಂಪರೇಚರ್ ಬೇಡ ಆಗಿದೆಯಪ್ಪ. ಓಕೆ, ವಿ ಡೋಂಟ್ ವಾಂಟ್ ದ ಜಾಸ್ತಿ ಟೆಂಪರೇಚರ್. ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ವಿ ಆರ್ ಎಕ್ಸ್ಟ್ರಾಕ್ಟಿಂಗ್ ದ ಹೀಟ್. ಸೊ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ Le-Chatelier's principle, the system will be go in the direction where the heat is being evolved out, like exothermic direction where heat is actually released. ನನಗೆ ಹೀಟ್ ಬ್ಯಾಡ್ ಆಗಿದೆ, ಸೊ ಐ ಆಮ್ ರಿಲೀಸಿಂಗ್ ಇಟ್. ಸೇಮ್ ಲೈಕ್ ನಿಮ್ಗೆ ಯಾವಾಗಾದ್ರೂ ಹೀಟ್ ಆದ್ರೆ ದೇ ವಿಲ್ ಬಿ ಅಲ್ಸರ್ಸ್ ಇನ್ ಯೋರ್ ಮೌತ್, ಸಮಥಿಂಗ್ ವಿಲ್ ಬಿ ಹ್ಯಾಪನಿಂಗ್ ಇನ್ ಯೋರ್ ಫಾರ್ಮ್. ಓಕೆ, ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ವೆನ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ವಿಲ್ ಬಿ ಹ್ಯಾಪನಿಂಗ್ ಆಕ್ಚುಲಿ, ಅವಾಗ ನೀವು ಬಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂತ ಒಂದು ಟ್ಯಾಬ್ಲೆಟ್ ಇದೆ. ಓಕೆ, ದ್ಯಾಟ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಹ್ಯಾವ್ ಇಟ್. ಸೊ ಅದರಿಂದ ಏನಾಗುತ್ತೆ, ಹೀಟ್ ಏನಿದೆ ಅಲ್ಲ ನಿಮ್ಮ ಬಾಡಿಯಲ್ಲಿ, ದ್ಯಾಟ್ ವಿಲ್ ಕನ್ವರ್ಟ್, ಮೀನ್ಸ್ ವಾಟ್, heat will be released. Exothermic process is happening to your body. That's what here also it's happening. Clear? So exothermic reaction, and in the given situation, forward, there actually it was a backward reaction. Endothermic ಅಂದ್ರೆ ಬ್ಯಾಕ್ವರ್ಡ್ ನಲ್ಲಿ ಆಗ್ತಿದೆ. ಓಕೆ, ಬ್ಯಾಕ್ವರ್ಡ್ ನಲ್ಲಿ ಅಪೋಸಿಟ್ ಟು ದ exothermic. Okay, exothermic reaction, forward reaction will be favored, that is formation of NH3 till the new equilibrium is again established. Clear everyone how the things are happening? Endothermic and exothermic process according to the temperature, how it's been reacting to form the reactions also. Okay, to form the reactions also means what? To decompose the temperature is sometimes increasing, sometimes it's decreasing. So ಇವೆಲ್ಲ ಆಗೋದು ಎಲ್ಲ ರಿಯಾಕ್ಷನ್ ಜೊತೆ. ಓಕೆ, ಯಾವುದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆಗಲಿ ಅವೆಲ್ಲ ಆಗ್ತಿದೆ. ಜಸ್ಟ್ ಥಿಂಗ್ ಇಸ್ ವಿ ವಿಲ್ ನಾಟ್ ಬಿ ನೋಯಿಂಗ್ ಇಟ್. ಸೊ ಸ್ವಲ್ಪ ಗೊತ್ತಿರುತ್ತೆ, ನಾಲೆಜ್ ಇರುತ್ತೆ, ಸ್ವಲ್ಪ ರಿಯಾಕ್ಷನ್ಸ್ ನಾಲೆಜ್ ಇರಲ್ಲ. ಓಕೆ, ಇನ್ನ ಎಷ್ಟು ರಿಯಾಕ್ಷನ್ ಇದೆ, ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಿದ್ದೇನೋ, ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತಿದ್ದೇನೋ, ಅದು ಯಾರಿಗೂ ಐಡಿಯಾ ಇರಲ್ಲ. ಆಯ್ತಾ? ಸೊ ಯಾವಾಗ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೇವಲ್ಲ, ದಟ್ ಟೈಮ್ ವಿಲ್ ಹ್ಯಾವ್ ಆಕ್ಚುಲಿ ದ ಐಡಿಯಾ ಅಬೌಟ್ ಇಟ್. ಓಕೆ, ಅವಾಗಷ್ಟೇ ಐಡಿಯಾ ಗೊತ್ತಾಗುತ್ತೆ. Next comes the effect of a pressure. So increase in pressure would result in decrease in the volume. So ಯಾವಾಗ increase ಆಕೊಂತ ಹೋಗುತ್ತಲ್ಲ pressure, that would result in the decrease in the volume. Okay, pressure will increase, volume will decrease. Now, thereby increasing the concentration. So, for that purpose, increase of concentration. Clear? So, the system will be shifted to shift in the direction where the number of the moles will decrease. So, this is system, what is happening? This is system. So, this is system will in system that will directly means where the number of the moles also will start decreasing. Number of moles is moles of number per beta node. So in that system, whatever is there, that will shift. It will shift. System will shift to number of number of the moles will decrease. Then now decreasing the concentration. So in given situation, this will make to decrease in the concentration. Okay. Now this will make yes, there is a decrease in the number of the moles in forward direction. So there will be a decrease in the number of moles of a forward direction also. So the increasing pressure favors forward reaction. So for that purpose only, increasing pressure. What is increasing the pressure is there, no? That will favor to the forward reaction itself. Sorry. Okay, that is formation of a NH3. There will be a formation of a NH3. Clear? Then next, decreasing the pressure would mean lower number of moles per liter. So yavaga decrease pressure decrease ಆಗ್ತಿದೆ ಅಲ್ಲ, there will be what? Decrease in the pressure would mean to the what? Lower number of moles per liter. So yavaga pressure decrease ಆಕೊಂತ ಹೋಗುತ್ತೆ, moles, number of moles also will start decreasing. Clear? Number of moles also will start decreasing. So the system will shift in the direction which will produce more moles. So ಅದರ ಸಲುವಾಗಿ moles ಕಡಿಮೆ ಆಕೊಂತ ಹೋದ್ರೆ ಸಿಸ್ಟಮ್ ಏನಿರುತ್ತಲ್ಲ that will transfer. Okay, ನನ್ನ ಕಡೆ moles ಸಿಗ್ತಿಲ್ಲಪ್ಪ, moles ಬೇಕಲ್ಲ ಮೇನ್ ಇವ್ರಿಗೆ, ನನ್ಗೆ ಸ್ಟೇಬಲ್ ಆಗೋದಿದೆ, ನಂಗೆ moles ಬೇಕು, ನನ್ನ ಕಡೆ moles ಇರಲಿಲ್ಲ ಅಂದ್ರೆ I will shift to I will go to somewhere else. ಈಗ ನಿಮಗೆ ಏನೋ ತಿಳಿತಿಲ್ಲ ಅಂದ್ರೆ you will go to shift to something else, right? So ಸೇಮ್ ಅದೇ ತರ ಇಲ್ಲಿ ಆಗುತ್ತೆ. ಆಯ್ತಾ? So the produce more moles in given situation, there is an increase in number. So there will be an increase in the number of molecules, number of moles in reverse direction. So the decreasing pressure favors backward reaction. For that purpose only, whatever decrease in the pressure is happening, that is happening in the backward reaction. Means what? Reversible process. Product in the reactant ಆಗ್ತಿದೆ. Okay, product in the reactant ವರೆಗೆ ಹೋಗ್ತಿದೆ. Clear? That is called as decomposition of NH3. That is also called as what? Decomposition of NH3. Now, what is the effect of a concentration? What is effect of concentration? The concentration can be changed in two ways. The concentration can be changed into two ways. What are those two ways? By removing some of the component. Okay, ಸ್ವಲ್ಪ components ತೆಗೆಯಬಹುದು. We can remove some components. Okay, and by adding some more components, means what? Whatever the concentration is there, no, the concentration that can be changed. Means what? ಹೇಗೆ change ಮಾಡ್ಕೋಬಹುದು? In case ನಮಗೆ concentration ಜಾಸ್ತಿ ಮಾಡ್ಕೊಳ್ಳೋದಿದೆ ಅಂದ್ರೆ ಏನು ಮಾಡಬಹುದು? We can remove some components in it, then or else we can add some components in it where to dilute it. If you want to make it concentrated, then we will add some chemicals, bro. We will add it, then it will happen, right? Clear? Okay, mistakenly bantappa, okay? Next, effect of catalyst. So next comes the effect of catalyst. Then we have, yes, we have evolution of KH, and then effect of pressure on melting point, vapor pressure of the liquids. Okay, few things are left out now. Okay, effect of catalyst ನಲ್ಲಿ ಏನಾಗುತ್ತೆ? Catalyst will increase the rate for both the forward and backward reaction. Okay, catalyst will start increasing. It will start increasing rate of the both forward and backward reaction simultaneously and to the same extent. At the same extent it is going to happen. Okay, in a reversible reaction, by an increase in both rates, it reduces the time to reach the equilibrium state. To reach the equilibrium state. Clear? So, in kelsa actually catalyst do? Catalyst will do only one work. Catalyst work is to increase the temperature. Means what? So, ಏನು ಒಂದು ರಿಯಾಕ್ಷನ್ ಆಗ್ತಿದೆ ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ನಲ್ಲಿ. ಓಕೆ, ಅದನ್ನ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಮಾಡ್ಲಿಕ್ಕೆ ಫಾಸ್ಟ್ ಆಗಿ ಬೇಕಿದೆ. ನನಗೆ 5 ನಿಮಿಷದಲ್ಲಿ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಏನೋ ಬೇಕಿದೆಯಪ್ಪ. ಓಕೆ, ಸೊ ಈಗ ಅಕಸ್ಮಾತ್ ನಾವು ಕೆಟಲಿಸ್ಟ್ ಅನ್ನ ಹಾಕಿದ್ವಿ. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್, ನೀವು ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತೀರಾ, ಏನೋ ಕುಕಿಂಗ್ ಮಾಡ್ತಿದ್ದೀರಾ, ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬಿಡ್ತಾರ. ಸೊ ದ ಥಿಂಗ್ಸ್ ವಿಲ್ ಹ್ಯಾಪನ್ ವೆರಿ ಫಾಸ್ಟ್. Right? Same way like that only we are adding up the catalyst there to get the product in a very less time. So for that purpose, catalyst is being used actually. Clear? So that effect, how it is going to form in the backward and the forward reaction, that they have told it. Okay, that is catalyst will increase the rate of both. Means what? The catalyst is actually helping forward reaction also and the backward reactions also. Clear? So same extent the reversible reaction is going to happen. Means what? Increase in both the rates, it will reduce the time to reach the equilibrium state. Okay, it will reduce the time to equilibrium state. Clear? Next, catalyst does not change the relative amounts of either reactants or products, therefore it has no effect, no equilibrium constant. Okay, so catalyst will does not change any relative amounts of either reactant side nalli ಮತ್ತು product side ನಲ್ಲಿ ಏನು changes ಮಾಡಲ್ಲ. Okay, ಏನು changes ಮಾಡಲ್ಲ, just ಏನು ಮಾಡುತ್ತೆ ಅದು, that will actually not affect also on the equilibrium constant, just they will help to form the product faster way. That's it. ಏನು ಚೇಂಜಸ್ ಮಾಡಲ್ಲ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಮೋಲ್ಸ್ದು ಮತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ಮೋಲ್ಸ್ದು ಏನು ಚೇಂಜಸ್ ಆಗಲ್ಲ ಅದರಲ್ಲ. ಓಕೆ, ಕೆಟಲಿಸ್ಟ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ತಪ್ಪಪ್ಪ ಅಂತ ಯಾರೇನು ಹೇಳ್ತಿದಾರಲ್ಲ, ರಾಂಗ್. ಓಕೆ, ಇಫ್ ಇನ್ ಕೇಸ್ ಸಮ್ ಸೈಂಟಿಸ್ಟ್ ಆರ್ ಟೆಲ್ಲಿಂಗ್ ದಟ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್, ಎವಲ್ಯೂಷನ್ ಆಫ್ ಅನ್ equilibrium constant K at a different temperature. So different temperature ನಲ್ಲಿ ಹೇಗಾಗ್ತಿದೆ ಅದು. So if K1 be the equilibrium constant at T1 in Kelvin and K2 be the equilibrium constant at T2 in Kelvin, the temperature T2 is actually greater than T1. If in case temperature T2 is greater than the T1, then the two constants, that is K1 and K2, are related by Van-Hoff's equation. So it is related by what? Van-Hoff's equation. So how it's going to be defined? Log of 10 K2 divided by K1 is equal to delta H naught divided by 2.303 R T2 minus T1 is divided by T1 minus, T1 into T2. Right? So log of 10 K2 divided by K1, equilibrium constant of K2 and equilibrium constant of K1. So according to that, delta H naught is actually divided by 2.303 into R. R is a constant. You know already what is the constant of R. Now T2 minus T1 divided by T1 into T2. Then where delta H naught is the standard heat of the reaction and R is the gas constant. Clear? So delta H, in consider delta H naught is a standard heat. Okay, that is going to be the standard heat of the reaction and R will be the gas constant. Okay, now later this principles and the physical equilibrium, what it tells us, consider the physical equilibrium of change of a state solid to the liquid, then what happens, it's going to be changing. Okay, pen ಬಿದ್ಬಿಟ್ಟು. ಸೊ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಲೇಚರ್ಸ್ ಪ್ರಿನ್ಸಿಪಲ್ ನಲ್ಲಿ ಫಿಸಿಕಲ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ನಲ್ಲಿ ಸಾಲಿಡ್ ಯಾವಾಗ ಕನ್ವರ್ಟ್ ಮಾಡುತ್ತೆ, ಲಿಕ್ವಿಡ್ ನಲ್ಲಿ. ಓಕೆ, ಸಾಲಿಡ್ ವೆನ್ ಇಟ್ ವಿಲ್ ಗೆಟ್ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ಟು ದ ಲಿಕ್ವಿಡ್, ದಟ್ ಟೈಮ್ ವಾಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾಪನ್, ಏನಾಗುತ್ತೆ ಅವಾಗ. So now let's move to the next part, that is effect of pressure on the melting point. So this will be the last concept. When a solid will melt, there is a decrease in the volume for some solids. Okay, there is actually a decrease in the volume for some solids, that is ice, quartz and carborundum, where the magnesium titride, diamond, etc. And there is an increase in the volume for some solids also, like example gold, silver, sulfur, copper, iron, etc. So now what happens with the of ice, this causes what? Decrease in the volume. Yes, it will cause the decrease in the volume. Why it will cause the decrease in the volume? Why? Because when you're going to start melting the ice cubes, that time the volume will be less, and how much volume you have added and how much volume what you will get it after you melt it, that will be little different. So only the decrease will be volume will be happening. So for this type of system where there is a decrease in the volume due to the melting, increase in the pressure will be reduced. Okay, increase in the pressure will be reducing in those cases, and the PMP of the system, thus the increasing the pressure will favor the melting of the ice. So for that purpose only, the pressure will favor the melting of ice. The pressure will favor the melting of ice. So similarly, increase in the volume is caused due to the melting of sulfur. It is caused to the melting of a sulfur. For this type of a system where there is an increase in the volume, due to the melting, decrease in pressure will reduce the melting point of the system. Therefore, thus the decrease in the pressure will favor the melting of the sulfur. So for that purpose only, whenever you are decreasing the pressure, that will actually favor to the melting of a sulfur easily. Clear? So how the pressure is actually affecting to the melting, that you people need to understand. Simple example ತಗೋಬಹುದು about the ice cubes also, how I told you. So ice cube ತಗೋತೀರಾ, ಎಷ್ಟು ವಾಲ್ಯೂಮ್ ಹಾಕಿರ್ತಾರಲ್ಲ ice cube ಮಾಡ್ಲಿಕ್ಕೆ, ಆ ice cubes ಅನ್ನ ಯಾವಾಗ ಮೆಲ್ಟ್ ಮಾಡ್ತಿರಲ್ಲ ಅಷ್ಟೇ ವಾಲ್ಯೂಮ್ ಇರಲ್ಲ. It's happening because of the pressure. Clear? It's happening because of the pressure. Next comes vapor pressure of the liquids. So considering the liquid vapor equilibrium, it is an endothermic reaction towards forward reaction. Therefore, rise in temperature will support evaporation. So whenever you are rising the temperature, it will support the evaporation. So temperature rise ಮಾಡ್ಕೊಂತ ಹೋದ್ರೆ evaporation ಜಾಸ್ತಿ ಆಕೊಂತ ಹೋಗುತ್ತೆ. So ಸಮ್ಮರ್ ಸೀಸನ್ ಅಲ್ಲಿನೇ ಜಾಸ್ತಿ ಆಗೋದಲ್ಲ evaporation compared to the rainy season and winter season, right? Because the temperature will be more in the summer season. So the rise in the temperature will support the evaporation. This means increasing temperature results in increase in vapor pressure of the system. Vapor pressure of the system. Next comes the effect of pressure or on boiling point. Okay, clear with the pressure about the melting point. Now let's go to the boiling point. So with increasing the pressure, ಯಾವಾಗ ನೀವು increase ಮಾಡ್ಕೊಂತ ಹೋಗ್ತಾರ pressure ಅನ್ನ, ಅವಾಗ system ಮೇಲೆ liquid vapor, that is vapors condense, lowering the vapor pressure of the system. So what will happen here? The vapors will condense, lowering the vapor pressure of the system. So vapor pressure of that system will start decreasing. Okay, it will start decreasing when you apply the pressure to that. Okay, so this means what? Boiling point rises with increase in the pressure. Boiling point will start increasing with rising in that pressure, rising in the temperature. BP, that is melting point, will rise with increase in the pressure. It's increase in the pressure. Temperature, pressure, full confusion. Okay, so don't get confused here. Just be focused while learning it. Okay, so BP will rise with the increase in the pressure. So boiling point will actually increase. It will increase in pressure as the pressure required for the liquid to start boiling. It needs to be increased. Okay, needs to be increased. So ಏನಾಗುತ್ತೆ? This means what? The boiling point ಯಾವಾಗ ರೈಸ್ ಆಕೋತ ಹೋಗುತ್ತಲ್ಲ ಅವಾಗ increase ಆಕೊಂತ ಹೋಗುತ್ತೆ. ತಿಳಿತಾ? So ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ pressure has a reach, the pressure required for that liquid will start boiling. It will start boiling the liquid. Okay, for that purpose it will need to be increased. ಯಾವಾಗಲೂ it will start increasing. Okay, it will start increasing. Next, last concept, I guess. Yes, this is the last concept. So effect of temperature on solubility. So generally the formation of a solution, that is solute in solvent, is an endothermic process. It's always an endothermic process because heat it is actually observed from the outside. Clear? So for such cases, increase in temperature increase the solubility of the solutes. It will increase the solubility of the solutes. So for that purpose, in that case, where dissociation of the solute is followed by the evolution of the heat. By the evolution of the heat. Means what? The heat has been observed from the outside. Okay, endothermic process is happening there. Clear? So increase in the temperature. ಯಾವಾಗ ನಾವು increase ಮಾಡ್ಕೊಂತ ಹೋಗ್ತಾರಲ್ಲ temperature ನ, ಅವಾಗೆಲ್ಲ the lower the solubility of the solutes. So solubility will get less. Solubility will get less when you are increasing the temperature. Solubility will decrease. Okay, when you increase the temperature, solubility will decrease. Clear? Next, what happens in the solubility of gaseous in liquids. Okay, gaseous in liquids. If in case with increase in the temperature, the solubility of the gas will decrease. Clear? So with increase in the temperature, whenever you increase in the temperature is happening, the solubility of the gas will also decrease. Solubility will also decrease. Clear? So that time what happens, this applies that with lower temperature. So kadame temperature iddaga more gas is present in the solution. Gas ಯಾವಾಗ ಕಡಿಮೆ ಇರುತ್ತಲ್ಲ, pressure solution ಜಾಸ್ತಿ ಇರುತ್ತೆ. Solution will be more when the gas will be less. Means what? Gas ಕಡಿಮೆ ಇದ್ರೆ solution. ಈಗ ಸೇಮ್ ಸ್ಪ್ರೇ ಇರುತ್ತಲ್ಲ ಪರ್ಫ್ಯೂಮ್ ಬಾಟಲ್ಸ್, ಅದು ಹಾಗೆ ಗ್ಯಾಸ್ ಯಾವಾಗ ಕಡಿಮೆ ಇರುತ್ತಲ್ಲ ಅವಾಗ ಲಿಕ್ವಿಡ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಟೇಕ್ ಅ ಲಿಕ್ವಿಡ್ perfumes more compared to the gas. Okay, compared to the solution with the higher temperature. Clear? Simple example, perfume bottle. Okay, next comes effect of the pressure on the solubility. Okay, how the effect of the pressure is there on the solubility. There is a decrease in the volume of the gas. So volume of the gas will decrease. So it will decrease. That is X, which is in the gaseous form, it will convert to the X in aqueous form. When a gas is being dissolved in the liquid, when the gas is being completely dissolved in the liquid, therefore increase in the pressure will favor the dissociation of the gas in the liquid. Okay, ಯಾವಾಗ ನೀವು ಪ್ರೆಷರ್ ಅನ್ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ತಾರಲ್ಲ ಅವಾಗೆಲ್ಲ ಏನ್ ಫೇವರ್ ಆಗುತ್ತೆ, ಡಿಸೋಸಿಯೇಷನ್ ಆಫ್ ದ ಗ್ಯಾಸ್ ಇನ್ ದ ಲಿಕ್ವಿಡ್ ವಿಲ್ ಬಿ ಫೇವರ್ಡ್ ಮೋರ್. ಕ್ಲಿಯರ್? So this is all about the today's chapter. Okay, today's chapter is all about the chemical equilibrium. ಎಲ್ಲ ಬೇಸಿಕ್ಸ್ ಅನ್ನು ಹೇಳಿದೆ ನಿಮಗೆ. ಫುಲ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ಸ್ ಯಾವ್ಯಾವ್ದ್ರಲ್ಲಿ ಯಾವ ತರ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಕೇಳ್ತಾರೆ ಅನ್ನೋದು ಹೇಳಿದೆ. ಸೊ ಮೇಕ್ ಶೋರ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ವಿಲ್ ಸಾಲ್ವ್ ಅಬೌಟ್ ದ PYQs ರಿಲೇಟೆಡ್ ಟು ದಿಸ್. ಸೊ ಅದಕ್ಕೆ ಫುಲ್ ಪರ್ಫೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡ್ ಬನ್ನಿ. ಇನ್ನಾದ್ರೂ ಯಾರು ನೋಡಿಲ್ಲ ಅಂದ್ರೆ ಗೋ ಚೆಕ್ ದ ಡಿಫ್ರೆಂಟ್ ಚಾಪ್ಟರ್ಸ್ ಆಫ್ ದ ನೀಟ್ ಆಲ್ಸೋ. ಸೊ ಅದನ್ನೆಲ್ಲ ಥಿಯರಿಯನ್ನ ಫುಲ್ ಪರ್ಫೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. After that, we'll do the PYQs perfectly, because ನಾನು ಹೇಳಿದ್ದೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಇಂದ ಹೇಳ್ತಿದ್ದೇನೆ, ಥಿಯರಿ ಪರ್ಫೆಕ್ಟ್ ಇದ್ರೆ PYQs ಮಾಡ್ಲಿಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ. ಕ್ಲಿಯರಾ? ಸೊ ದೆನ್ ಸಿ ಯು ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್. ಬಾಯ್ ಬಾಯ್.